Okay, so welcome to the data science track. Good morning, everybody. Now we are going to hear the first talk where we talk about visualizing the data in the Open Data Hub. It's a very nice project done by the Neuss Tech Park, where this product should visualize all the data that is in the Open Data Hub. So this is a huge project going on since several months, and we have the main developer here, Christian Gapp. So floor is yours.
Hello, everybody. So let's start. This is already a bit too far. So I'm talking about the data browser for the Open Data Hub. My name is Gapp Christian, as Martin already introduced. So the first question is, what is the Open Data Hub? The idea of the Open Data Hub is to have a single access point to all the open data of South Tyrol. So it covers different domains. At the moment, those are the tourism domain, the mobility domain, and the others domain, whereas the others domain contains data sets that don't belong to the domains mentioned before. The Open Data Hub itself has a lot of data. And the question now is how to make that data available to the people. And it makes that data available through different endpoints, for example, using REST API, but there are also other technical possibilities to access the data. Now, one big question is how do you promote that data to the people so they can access it? As I said before, there is, for example, a REST API. And the REST API is okay for developers, but REST APIs are not accessible for ordinary users. For example, my mother won't be able to access a REST API. She knows how to use a web browser, but that's it. So another problem is that REST APIs lack discoverability of data. So if you access a REST API, usually you don't know really what data it contains and where to find guidelines on how to use it. And another problem is that REST APIs usually don't have guidelines for new visitors. So if you the first time access a REST API, you encounter some technical stuff, but you don't really know where to go and where to find new information or information about the data that it provides and how you can interface with the API. Now the solution to these problems envisioned by Neuss was the data browser. There is a current version of the data browser, but I'm talking now about the new version of the data browser. So, sorry, I think this is the right button. Now the goals for the data browser are to promote easy access to the Open Data Hub data, as I said before. And there we start with the tourism domain. Another goal, an important goal, was to focus on the user experience, so the users don't get repelled by the data browser, but they want to use it. Another goal was to make it configurable, and that allows for non-technical users to adapt it to their needs to some degree. And it also allows to make new data sets accessible without changing the code. So if new data sets get added to the Open Data Hub, then you should be able to use them with the data browser without needing to modify the data browser itself. Another goal was to provide tools for developers, because developers are an important target audience for the data browser itself. Now, I find it's always nice to have some visualization so you know what the speaker is talking about. So here you see some screenshots, the most important ones. There are a lot of other views, but those are, it's a sample of the screenshots. For example, you see on the list on the left top, you see a list of the data sets that are available. This is a curated list. It's not all the data sets. It's a specific subset where we thought this is the most important and interesting ones. Then we have a data set overview where you get some more information about the specific data set. We have a list of records for a given data set, so you can paginate through and look a little bit what data it contains. And then we have views in on different levels. where you can see what a record provides. So for example, here you have detail view, we have JSON views, we have nicer views, we have also edit views where you can modify the data if you are allowed to, and so on. So there's a lot of stuff. Now to the challenges. The Open Data Hub, the datasets inside the Open Data Hub and the domains sometimes differ in their structure, meaning they differ in the properties that they have, but also sometimes in, for example, the naming of the properties. And that's a bit of a problem because we want to provide a unified view to the data using the data browser, and therefore we need to find common denominators on how to present that data. So this was, and still is, a bit of a challenge. Another challenge was that we want to provide a pleasant user experience, so that you like to use the data browser and don't say, let's put it aside, maybe better to access the REST API directly. And yeah, to meet that challenge, we work with a team of experts that help us to develop the user experience. Then another challenge was to make the data browser configurable. For this, we combine the data from the Open Data Hub with a description of the data. And for example, it's Open API. Could be one type of description that we actually use. And if we combine those things, we can render our user interface. And this allows us to make it configurable. Another challenge was to make the developers happy. We put some effort into thinking what developers want to have and what could help them in their development life. Now, to the development process itself, we use iterative increments, where each increment provides a new set of features. So after each iterative step, the data browser has some new features that you can try out and that hopefully work. We have recurring meetings with different focus. So some of the meetings focus on the user experience and user interface, which is an important topic that we would like to provide as good as possible. There are meetings that focus on development and implementation. We have also meetings where we get feedback and solutions from our customer care team. So those are really important folks that help and that are involved in the creation of the whole data browser. The final goal is to provide a productive solution of the data browser by the end of the year. Now, the current status. The data browser itself is deployed in a public test environment and is accessible to anyone. So if you have the link, and the link is at the end of the slides, so if you're interested, you can take a look at the slides. You can access the data browser already now and take a look at it, how it works, and if you like it. And we would encourage you to do so, and we also would like to have your feedback, because that's important to us and also for the evolution of the data browser. The overview and guiding principles are implemented, so you should get some directions on how to work with the data browser, what it provides, what it is, and how to use it, and also how to use the Open Data Hub itself. Now, the dataset details on different levels are implemented. As you have seen before, on the screenshots, there is quite some stuff where you see the data that the Open Data Hub contains. The configuration framework is implemented and in effect, so it works. We had some proof of concepts, and we know it works, and yeah, it's implemented. And developer tools exist for the developers. I think there are a lot of developers here. And you can try them out and see if it provides the stuff that you need. Now finally, to the outlook. Until the productive release at the end of the year, we want to stabilize and fix bugs for the data browser. And then from 2023 and onward, we want to add features like filters search, and many more. So stay tuned and take a look at it. Thank you very much for your attention. Do you have questions?
Thank you, Christian. Other questions? There's a question. Do we have a microphone? Thank you.
Just one question for developer. For example, you have developed this browser application, but you have used HTML5, plain JavaScript. Some details about how you implement this kind of stuff. We can find online for
So
the project.
the question
Because
was,
the question was, okay, you provide tools for developers. Which kind of tools? Because developers, JSON, widget for visualize data or some indication, or I don't know, is not specified here in the. Yeah, thank you.
So thank you for the question. What we do provide at the moment are not widgets, so it's not graphical stuff. Some of it is graphical, but not that elaborated stuff. What we provide, for example, is you get the request that is sent by the data browser and that is used to interfere with the Open Data Hub. You can get that very easily. So there's a part where you can copy that request and where you can take a look at the data itself. We have tools where you can export the data in the form of JSON and access the data as JSON. We have other tools, for example, when you want to edit the data, where we have a JSON diff. So you see on one side what is the current status of the data, and if you modify the data, what would be saved and sent to the data browser. And these are some of the tools. So we are we are progressing, and we want to improve the tools and also put new tools where we see they could fit.
Maybe I can add here that normally developers, when they look at an API, they have Swagger, so the classical way to see how the API is built. And with the data browser, it's one goal to visualize the data for a user which is not a developer, but at the same time to have a part on the screen where you see exactly the call you would see in Swagger. So you can, as developer, you can look at the data, but you can copy and paste the call and copy to your command line and just get the data via JSON like there. So this is kind of the tools Chris is describing, and they're pretty, you don't see them generally in a data browser, because a data browser is kind of hides everything too complicated, let's say. So, other questions? Doesn't know. We wait for the microphone, so. Thank you.
Is there a way for us to contribute to the development, or is this something, is there a GitHub repo or something like that?
Yes, so there is a GitHub repo. It's everything is open source, and it would be very nice if you contribute, or if you just look at the code. But if you see, okay, this could be improved, or if you have questions or discussions, just go to the GitHub project and contribute there, or you can also send emails, however you want. It would be really nice, and we would like you to contribute.
Thank you.
Thank you.
So make sure you leave your contact here afterwards, so we can get in touch. Other questions? We have a minute left, so I have a question. What do you think was the most difficult part? I know that's a bastard question, but what was the most difficult part on creating this data browser?
Yes, one of the most difficult parts was the configurability of the data browser, because we had to find some way to render the user interface by using declarative configuration of the UI. So we had to define a configuration, look how it works out, and to implement the whole stuff to render the UI based on that configuration. And that was quite some work, but it seems to work.
Mm-hmm. So perfect in time. Okay, thank you very much, Christian.
Thank you.
So that's it for the first talk. We have now a 5-minute break. You can change to another track or stay here. The next talk will be about data-driven decisions in agriculture. So see you in a couple of minutes. Ja, quello con la mano. Aspetta.
Platz? Hallo, hallo? Ist er da so? Ja.
So, welcome back to today's data science track. So we have now our next speaker here. He's Johannes Aschbamer, working at Converter. And he's talking about Know Your Farm and how data-driven data is transforming the knowledge about the farm and influencing the decisions. So, welcome, Johannes. The floor is yours.
Thank you very much. So, agriculture these days faces a lot of different challenges. The most obvious ones are the growing population and the climate change. So this month, actually, we will pass 80 billion people on the planet, and until the end of the century, we will be 10 billion people. This is combined with the biggest challenge in human history, which is the climate crisis. As a result, we have to produce more food, more quality food, and at the same time use less land, less water, less resources in general, which is very difficult. And additionally, we have other problems on the horizon, like the demographic change and the fact that every day people are moving from rural areas into big cities. And on top of all that problems, we have consumers that demand cheap food that in the best case is also produced organically. So agriculture needs to address a lot of different challenges at the same time. And in order to do so, humans did what humans always do when they have a problem, and that is inventing stuff. So let's have a look at irrigation techniques, for example. A very old and simple irrigation technique was to just flood the land with canals. Nowadays we are using, or in last decades we have used water sprinklers that are easier to use and more effective. And in the last years there was a strong move into drip irrigation. If you combine the last technology with sensors that are measuring the soil moisture, then we have a very effective way to water plants, because they are just receiving that much water that they really need to grow fruits. Another example that is especially relevant for South Tyrol is apple harvest. So decades ago, people used to climb these very big trees with lots of people to do the harvest. Nowadays, we are using semi-automatic machines that move apples with moving belts into big boxes, basically. And the newest advancements in that field are fully autonomous robots that are able to collect apples on different apple orchards. Then we have another example here, which is crop protection. So again, decades ago, farmers used way too many pesticides to improve their yield and to ensure quality. Nowadays, we are using a new spraying techniques that uses less pesticides and also reduce the drift from the farm. But in the future, we might be able to reduce the usage of chemicals to a very minimum by using the work power of robots. This example here, for this robot here, for example, can work autonomously in almond farms. It identifies mummy almonds, which is basically bad almonds with quality problems, and shoots them down from the trees. Totally automatically. And this robot does not get tired. It can work 24 hours, and it's also not labor intensive for humans. It's just automatic. So we see a lot of advancements in that field, but there's one ingredient that connects them all and is crucial for technologies to evolve in this field. And that is data. And data is needed for all these new technologies. We need to understand when plants are thirsty, when they need to be watered. And we need also a lot of data, for example, to identify a ripe apple or a bad almond. At Converter, we saw this trend in agriculture, and that there is a strong need for data. And that's why we started 2 years ago a project called Cultivas. Cultivas is a big data platform that aims to help the local fruits cooperatives in South Tyrol and organizations to make better decisions in the field of agriculture. So what we want to do is we combine a lot of data from different sources with science, which means basically machine learning models, in order that the people in our homeland can make better decisions in this field. This is a very simplified overview of our architecture of the platform. So what we have on the left side is we have different data sources, like for example the Open Data Hub from Neutechpark or the Open Data Portal from the province of South Tyrol, but also some databases that are proprietary and closed from our partners. We import them into our system. We are using Databricks for that. These are workflows in Databricks that run every day. And then we are storing this data in a big data storage, which is called a data lake. On top of all that data and these technologies, we are creating some models that help to generate predictions for our customers, but also to interpolate data. The results from all this process is then stored in a geospatial database. We are using Cosmos DB for this task. We are also uploading data to 2 different mapping services. We are using ArcGIS and Mapbox for this. And as an API endpoint, this is the almost last step here with the thunderstorm lightning sign. We are using Azure Functions to create a REST API basically for our front ends. So now I want to give you 3 different concrete product examples that we are currently working on. The first one is a project that we have done last year in collaboration with Limburg Research, Eurac Research and Raiffeisenverband. So what we did is we created a model that predicts the output or the quality for different apple varieties in South Tyrol. We analyzed the apple color, the apple size and the yield that is estimated for a specific location. What you can see here is on a map where our model predicts better results in green and in orange and yellow worse result for a specific apple variety. We also saw that the model results change very strongly. They are very different for each location and each apple variety and parameter combination. The user can also select a specific field, and then you can basically compare which apple variety performs best predicted by our model. This year we started another project called Atlas. So we are currently working on this front end, on this product, and it incorporates many learnings that we had with our first project, which is one of them is that our customers have a strong need to see also the raw data, and they have a very strong desire to see climatic data for specific fields. And that's what you can see here. You can basically select any location in South Tyrol, and the app gives you an overview about the conditions in that specific location. For example, slope, exposure, sun hours, radiation, precipitation, vegetation days, and we also have some agronomic indices like the growing degree days index. We also have maps in this web app available. This, for example, is a map that shows the solar hours in October in South Shore, in Val Venosta. But the feature that we are most proud of is map filters. It allows to identify locations in South Shore that meet specific parameters. So we hope that this tool can help decision makers to identify good locations for crops that need different parameters, that they can run experiments on and find good locations for crops. What I have done here is I have selected one filter that just highlights all the locations that are below 900 meters. Then I combine this with another filter that filters out all locations that do not have at least 11 degrees Celsius temperature change in October. So we lose some areas here. And then we can add another filter that combines it with daily sun radiation. So we want to have only locations that have at least 7 hours of daily sun radiation in October. Another one, we want to have only locations with 20 degrees slope, so we can use machines to run in the field. And if you combine it with a last filter, like we don't want to have typical temperatures around below 2 degrees Celsius in October, then this is the final result that we get. I want to highlight one last project very quickly. So next year we are doing another project together with EURAC Research, and what we want to do here is we want to analyze the impacts of climate change to the apple orchards and grapevines in South Shore. So we want to create maps for different climate models, but we want also to understand how different crops will react to climate change. And all these results will be available to our platform, to Cultivas. And again, we want to support our stakeholders and the cooperatives and decision makers to make better decisions for the futures, which plants and which crops to plant in South Shore. We will start with this project beginning of next year. So let's bring data together and make better decisions. Thank you for your attention, and if you want to connect, I'm on Twitter and LinkedIn. Thank you very much.
Very good. So, are there some questions? Can we have a microphone? No, we don't hear it on the streaming then. Thank you.
Is there a specific way for the implementation of these sensors that you have in to collect the data for like the soil or for the plants, for the health of a plant? Is there a specific way in these sensors are implemented, like with drones or some, I don't know?
Okay, so currently we are not, we do not have own sensors basically. We are just using the sensors that are used by the province of South Shore basically up to now. But yeah, our focus is more on the platform, and we work together with partners that have access to sensors or have already sensors in place basically.
Other questions?
Thank you very much for your presentation. So in data science, one of the big issues is the data quality, right? So it always valid, garbage in, garbage out. And this is what most of the time we tend to neglect when working with machine learning. So how is your data quality? Are you satisfied with your data quality? And what are you doing in order to really ensure that you're working on a data quality data set.
Yeah, that's a good point. So for the first project that I presented to you, the variety location project, we had lots of problems with data quality because we received the data from the cooperatives, and as you can imagine, it's historic data that goes back over 10 years, basically. And the biggest part of the work was to ensure that the quality is good, and we work together with the cooperatives to identify just bad quality, and this also resulted that we could not use all the data that they provided to us. So what we have done is we filtered out a big part of the data that was not suitable for our model. Yeah, that's true. So especially for the first project, this was an issue. And what we have done to address this, we worked directly together with the data providers and with the research institutes like ORAC that also has some experience there.
All right, so we are already over time, so this talk ends here. Thank you very much, Johannes.
Thank you.
And thank you for your time. This was the last talk for this track, so you might search another seminar. Thank you.
Woo! Mi senti? Sì, io sono un
Io sono preparatrice.
Hello, everyone. Welcome to the ICSOB track, the industry track. So ICSOB, it's the International Conference on Software Business, was a collocated event with SFSCon. And this is the industry track where we show a little bit of the ICSOB conference tailored for the industry. So as our first speaker today, we have Sylvia Bordin. and I will pass the word to you.
Okay, hello everyone, can you hear me well, even at the back? Yeah, great. So, thanks for coming. I wasn't expecting such a large audience, but I realized that this topic is a bit special for this kind of conference. So, let me introduce myself first. I'm a user experience designer. I'm not a developer, even though my background is in computer science. And I'm also a certified design sprint facilitator, which is the reason why I would like to introduce you to this kind of method in a specific talk. Right, so the design sprint is a 4-day process developed in Google Ventures that leads to the rapid validation of an idea. Of an idea means that we can talk about improving an existing service, creating a new product, redesigning an organizational process. So it's a very broad concept of idea. We use the design sprint for the rapid validation while aligning the team and stakeholders on the business goals that we want to address and before starting a strategic project. So basically we use this technique to assess whether an idea is viable or not before investing into a full-fledged project. Let me provide you with some context first. You may be familiar with some of these methods already. So on the left hand, I shouldn't be looking at slides, but on the left hand, you may be familiar with approaches such as the design sprint, the design thinking in this case, where you have a combination of divergent and convergent activities. So first of all, we diverge, into that we generate ideas, and then we converge, trying to select them and to prioritize them. On the other hand, you may also be familiar with methods such as the Lean Startup, which rely on a very short loop between the idea and the data that are needed to validate it. The design sprint basically draws from both of these kinds of approaches, and you will see why in a moment. So the design sprint basically retains examples of both these approaches, elements of both of these. So, right. Typical problems. Where does it make sense to apply this kind of method? First, let me provide you with some examples. So the first one is when you have a cross-functional team that finds it hard to align with common business objectives. So we have a team that's composed maybe of developers, designers, business people, finance, you name it, and they can't agree on what's the business objective that they should pursue. Another example, very common, regards teams that work towards unclear goals because either the project scope is changing repeatedly because the priorities and then the business goals are not clear, or they lack real data to ground the business decisions, which means that they have to rely on internal meetings and their internal knowledge, therefore not on data as we know them. Other examples include teams that are pressured to be innovative, but they don't have a method to do this. Remember that design sprint is a method, meaning that it has a process as well. Or you could have very long product development cycles that cause the team to just go on developing and never releasing. This usually causes the team to lose enthusiasm and the focus on what they're doing. All of these are situations in which the design sprint comes in handy and can solve several problems. So in a nutshell, the basic motivation to use this kind of technique, to use the design sprint, is that, first of all, as I mentioned, you can quickly validate new ideas before investing in an actual project. So potentially saving months of work and a lot of money. Then, because this is a participatory approach, so we put together different stakeholders in working for the same project, we achieve an alignment of these stakeholders on the objectives and on the challenges that they may face and that they want to address, of course. Then, because as you can see from the number of post-its that you will see in my slides, this is a visual approach. So you achieve a visual representation that allows you to provide a common reference to thinking. So on the one hand, because you're using a process, you're structuring creative thinking, which is usually what not happens in brainstormings. On the other hand, you obtain a visual representation. So you have a visual shared reference point for all of the concepts that you are discussing about. And finally, because this is also an iterative approach, you have an iterative verification of actionable outcomes. So you can check your ideas with data throughout time. But let me be more concrete on this by showing you the precise structure of the design sprint. This is a sample week of the design sprint in 4 days. Usually we iterate this week twice in order to get feedback. I would like to focus on the first 2 days for the talk of today. What do we do in this kind of week? First of all, you will see that the schedule is very strict. The activities are prescribed because this is a process. So impose a process on the creative thinking in order to ensure that we achieve an outcome and that this outcome has a quality. So first of all, we start from the Monday with defining a challenge. We have a divergent stage in which we generate ideas to understand what is the right problem that we want to solve. In the same day, we also start addressing how to create a lot of solutions to this kind of problem once we have focused it. We will see this part more in detail in a moment. On the second day, the Tuesday, we go on with this. We select among the different solutions that we have created, we select those that look most promising, and then we turn them into a storyboard. We start refining them into a narrative. Finally, in these 2 days, we also engage clients. We have all stakeholders present on board all the time. This is very important. In the other 2 days, instead, we just have technical people, so specific skills engaged, because here we want to build a prototype that mirrors the solution that we have selected, and then we want to perform user tests to understand whether the solution that we have ideated can really matches with the data that we can collect from users and really fits their own needs and can be acceptable. Now, we will see some examples of these initial steps, let's say, to provide you with some more information on what they entail. First of all, we talk about the Monday. In this case, we first have a divergent stage in which we collect information on the context, and then we have a convergent stage in which we prune out all this context. We try to select what the information most important are, and we use them to create solutions. How do we do this? So first of all, we use some techniques to work on the context, to understand what the context of the problem that we want to address is. And we do so as the very first step, and I would like to insist on this because we set the scene for the rest of the activities. Some examples of these techniques include the expert interview, where we involve domain experts to get their understanding on the matter that we are dealing with, and we use these interviews to uncover opportunities. So the team that is listening to the domain experts will start writing these questions that start with how might we? Why do we do this? Because this is a technique that will force the team to reflect on the opportunities that lie behind the knowledge that the experts are sharing. So they will be forced to try to pinpoint what the real problem, the real question that we want to answer is within the project. We also use other techniques such as the map. We flesh out the customer journey as it is to highlight any pain points or any gaps in this customer journey, if this is the case of an existing product, for instance. Another idea is the lightning demos. In this case, we collect examples from other markets, other companies. We try to collect other ideas from contexts that are different from ours in order to compare our situation with others without jumping to a specific solution. We're just looking for inspiration in all of these 3 techniques. Why do we do this? Because solving the right problem beats solving the problem right. We need to know for sure what kind of problem we have to solve and what will bring the biggest business value or the value to our users before we start reflecting and implementing a solution. This concludes the divergence stage of the Monday, and then the next step is making sense of all this knowledge that we have gathered in concepts. So we start working on ideas, on proposals that can go from notes to a sort of a motivated deck. They get increasingly refined over the afternoon of the Monday, so that we arrive at a converging stage where we have summarized the knowledge into a set of solutions. At this point, what we do is also move to the next day. This is just done in one day. It's super quick. The next day, we start from the set of solutions that we have drafted, and we go through them in order to select the most promising parts of them. The way we do it is like this. We vote for the most interesting, the most promising parts of the solutions that can address the problem that we are set to solve. Then we proceed with summarizing the solutions, taking the bits and pieces that we found most relevant here, summarizing them into a prototype, and testing the prototype with the users. I will not go further into detail here, but in conclusion, what I wanted to point out is that why do we use the design sprint, and why can this technique be useful? So the market requires addressing digital transformation, to adapt to change, to make decisions very fast, and so forth. The design sprint offers a versatile instrument to address all of this. As you have seen, this is a process, and this can be applied to different sectors, different business areas, different contexts. Well, how does it do this? It adapts the principles of design thinking, including considering the point of view of people, business, and technology at the same time, to the time constraints that modern organizations have, while adopting a standardized process to validate the viability of an idea before investing into a full project, and while aligning stakeholders on the business goals. As I mentioned, this approach can be applied to different sectors, can be used to bring innovation in the company at different levels, from business, from management to development, for instance, while at the same time, again, reconciling different points of view and having a team work towards the same goals. This is it on my side. I will be happy to take your questions.
We have 2 minutes for questions. Anyone?
Yeah.
Okay, thank you for the presentation. And as far as I understood, this kind of process involves a lot of people, both internal to the company and external, a lot of actions and many things to do. So I assume the 4 days you presented are just how I was squeezing it, but in practice it will take more time, or where is the trick?
That's right. So the trick is here. First of all, you want to ensure that your key stakeholders are fully available for 2 full days, because then you have access to the knowledge that you need, to the business needs, and to a clear definition of these. If you don't have a clear definition yet, it will be there at the end of the 2 days. This is paramount. You don't have access to the stakeholders, you don't do a design sprint. Then the rest of the approach depends on the skills that are inside the company. So if you have these skills internally to design a prototype and to user test it, then all of this can be performed internally. Otherwise, you turn to a consultancy usually that will do the part of the prototyping and testing for you. But then again, the goal is this is not meant to be an approach that runs a project. This is just meant to check in the shortest time possible whether it makes sense to run a project. So it shouldn't ever go more beyond this kind of schedule.
Thank you very much. So
Thank you.
if you have further questions, you can talk to Sylvia, right?
I'll be here.
Now we have that 5 minutes break, but unfortunately the next presenter could not have a problem, could not be here today. So we are going to, let's say, wait for his presentation, so you are free to go, and we return at 2:40, right, with the presentation. So we're not going to have experimentation machine, and we come back at 2:40 with Orange. Yeah. Yeah, the thing is that Okay, so welcome back to the
Hello.
ICSOB industry track.
Someone of the younger guy, come in front. Don't stay spread there. Come on.
Okay, so I give you the word.
Thank you. First, I want to invest my first minutes in thank you the Unibids because they invite me. We met them some months ago. They explained what was amazing event that was going to be planned for November. We joined and do really happy. It's so unbelievable. Looks to be in San Francisco, not in Boston, not in IT way. Orange. I will spend a few minutes to explain who am I first and what I'm doing today, because that is required to better understand why Orange. Okay. First, I will go faster. 15 minutes are not. Who am I? I'm quite older, even if I was joking, stating that I'm in Kubernetes perspective. I have a container older, with spirit younger. I spend my life doing, I said company builder in one side, means I was an entrepreneur, I made some companies, and then I went in some international companies like Oracle, Cyber Systems, or last one was Accenture. To better understand, I wrote even 2 books about these arguments. Important point was that 4 years ago, we were with a company with 600 employees, and we sold all the group to Accenture. In the earn-out, we have been obliged to stay 3 years in Accenture. During that period, we start to mind what do next. There is someone who was talking about retire, finish, go to the beach and finish our working life, or do something different. The idea was to build a new company completely dedicated to the younger guy. And let me go here. And what came out in our mind before leave to have, this was our vision, means, I have to read it because it's quite complex, apply innovation, but the most important point was enthusiastic talent, means younger guys inside the company, visionary entrepreneur, some entrepreneur join with us. Today we have 24 entrepreneurs inside the company. No hierarchy organization. Forget vice president, senior vice president, senior manager, low manager, hyper, low manager, etc. We said, okay, we try to find a way to have an organization agile much as possible. And finally, really important, distribute the shares. Means we want to have everybody in the company as part of the company. It means that we are going to distribute 20% of the company in virtual share, tokenized on blockchain. Now we go better in the details. Where we are today, 18 months ago we were in 2, me and my friends, means 1st March to 2021. Today we are 281, spread in 5 companies that you can see here. Then I don't want to spend too much time explaining. But the important point is our 5 companies. We have offices in Berlin, München, because we start from München, not from Milan. We have offices in Milan, Rome, Madrid, Zaragoza, Lugano, and now we are open in France before Christmas. Why? Because we are collecting younger guys. Old office has about 20, 30 guys, and the total today is 221. Because I have to call my friends say how many we are this morning, because we are still taking younger guys, bring them in the company. Most probably will be double in 1 year. We are going to close this year with 24 million euros in revenues, net revenues. Why Orange? In this amazing, sometimes we say we are on nuclear bomb, sit on nuclear bomb, having so many guys working, customers, etc., not organized in hierarchy. The idea was we need to have an application that help us to run all those processes. And do not have found any application, and we decide to build or design, because it's not built, we are going to, our application. We made internal tests, and the name that came out was Orange. Why Orange or Orange, depending on how you prefer to call it. What, now I'll go faster here, what Orange should solve, should do. Important point, first, navigate the organization. This is organization 3D mappings. Means, assuming that some of a younger guy, you, join a company, we want to have an application where you can work on mobile, on the PC, and navigate it, understand not the hierarchy, but who do what, which are the container inside the organization, which are the container, which are the scope of part of the organization, who are the rule in that part of the organization, and who is doing that role. Means Giuliano is not the CEO. Giuliano is inside to that part of the organization, is managing the rule, and that rule means with all authorities, priorities, scope, objectives, key results that need to be achieved. And you can understand why Giuliano Monday morning wake up doing something. You must to flow or navigate in the company, understand not job position for the people, but what they do really do every Monday morning until Monday to Friday. Most beautiful if this is possible to do, navigating. The best will be Oculus, and we flow inside to my organization. I don't know if we will arrive to have Oculus, but in any case, the idea is to have these apps. Energize the rules means every time some of our guys has something to resolve, can decide the rules, describe the rules, and then publish it. Say, guys, I need a person, for example, let me give an example, responsible for the development of Orange in Bozen. This is the organization, development where Bozen, which are the scope of those or this role, and then understand if some candidates is coming directly from the company. Someone can say, okay, I want to run this job, I want to take ownership on this role. And we can link it, or find somebody from abroad. Then we have other, as you see, transparencies, for example. We have a full transparent organization. You can navigate and understand exactly everybody, what is doing, who is, which is his role, what is doing, which is his objectives, his responsibilities. Everybody will be full known without asking, making phone calls around the companies. Tension is an unbelievable problem. No? In many companies where I went, or in Accenture, some other biggest, you have problem in tension, you have conflicts. And we want to resolve the conflict, helping with some processes. Unlike in 12 minutes, I cannot explain you exactly what we have in mind as a process to run and solve or address the tension and the proposal. We doesn't want to have thousands of emails floating around the company and maybe forget somewhere. OKRs, someone of you knows OKRs, the Object and Key Results has been invented by Google, and we want to use it. We start to use using Excel. An Excel sheet with templates, but you can do for 20 persons, you can do for 30, you cannot do for 500. 500, you lost yourself in Excel. We want to have this type of processes inside. And finally, the most important, virtual shares. We are going to distribute before Christmas, this Christmas, 20% of the company in virtual share. We are not quoted, means we do not have price in the market. What we have in mind to take 20% of the company has been divided in 10 million shares. 20% will be distributed. The value, the enterprise value will be calculated on agreement with an algorithm, and we will give you the value of the company, and you can easily calculate how much are your shares. The question is, who will pay me these shares? Us. In the agreement, we will buy back the shares. If someone, the younger guy, will say, okay, I need to buy the car, I want to sell my shares. In the market, you go in the stock market, www, some stock market, and sell. In our case, we have this application, you can sell it, and the company is obliged to buy back at the price, enterprise value, that moment. All this stuff will be runs of this application. Means everybody will be an associate, will be not anymore an employee. Formerly, you had quotes or virtual shares of the company. This was, or will be, all our strategic organization application that everybody will use it. I have only 5 minutes, I will go very fast. This is something, is one mock-up. We have tons of mock-ups. These are mock-ups where you can flow in your hands, you can have all the organization. You can see the organization or in the satellite way, or in a bubble way, where you can see for any part of the organization, rule, authority, responsibility, members, names, surnames, teams, purpose, why we made this container inside the organization, what is needed to do what, or why we build it. Sorry, I want to go a little bit more here, because maybe it's the most interesting point. Virtual shares is like, who knows the application, like Apple apps, stocks that you can see. You can have your stocks inside to your application, understand how much is your part of the company. One next, okay, this was nice. I discussed with the team, the younger team, because I said I want to have something that always in the hands, I have not to explain how to use it. Someone say key, house key. Someone say mobile. I say, mobile is so stupid. I don't go in Bolzan state in mobile. Mobile is so stupid. And someone say me, toothbrush, spazzolino. Spazzolino, I have not to explain nobody how to use it. Everybody use every day. I want that your orange inside to our organization has the same feeling. I will not explain how to use. Easy to be used. I need that you have in your hands every day. Everything you need, orange. That is, I don't know if I have something more. Not. Behind the team, why Bozen? Because actually the team is, the initial part of the team is based on Bozen. We would like to extend, we are looking to extend our team in Bozen with the idea to have Orange fully developed in Bozen and spread it in all the organization. And this is the reason because I joined here today. I believe that I have not other, I will leave you for question. 3 minutes remain. Perfect, no? Sorry, I did a very long stream fast, but it's not easy to explain everything in a few minutes.
So we have a question here.
Yep.
Okay, how much time passes between the first idea and the realization of Orange?
The company has been built, the company, not the idea, the company.
No, the first idea in your brain, in your head.
18 months ago. Because
8 months.
we built the company 18 months ago, and then we start to think in one side how to build this company. And there is a business model that today is a few times I cannot explain how we grow up from 0 to 281 in few months. And even the idea to have this looks amazing organization, quite new, hierarchical. Let me say 1 year. 1 year in mind. And now we have to build the application because now we need it. We are becoming so bigger than we need it. We cannot continue to use paper or Excel or other apps.
Okay, and to complete my question, and at the very first time, 1 year ago, person involved was only one, you or
two?
Two. Okay.
No, we start with 2. Then we start with some friends that are coming from digital. Then we bring some guys coming from economies. Guys, I'm talking about guys between less than 30. We said, we will have this in mind, and they're up stating, we have holacracy, sociocracy, because not everything is completely new. We took from the literature some holacracy model, some sociocracy model, some not hierarchical model. We try to find what is better for us, and now we want to have this application to test it and tune it. The idea is to have an agile implementation of, means nobody knows if it works or not, until we will have first mock-up, first application, deliver to our team, and understand the return of testing. Someone explained design thinking before me. We will do the same process. We will do cycle or recycle until we will have the best one, and maybe we will push it on the market. Even in open sourcing, we are talking also to say, okay, if it works, maybe we can deliver in open source. Who knows?
Okay, congratulations, very good idea.
Thank you so much.
Final question.
Thank you. Very passionate speech.
Thank you. It's coming from here.
You talked about the visualization of the organization in Orange. Will there be some data for the single person, like salary and coins, shares, stuff like that? Everything in the open, fully transparent.
we doesn't want to substitute ERP or HR software. We will link it, actually we are linked to Odoo. Odoo is open sourcing for HR. The base data are coming from there. What are not supported is this way to build organization. It's more dedicated to organization. Obviously, if salary will come, address, mobile, from mobile phone you can find someone, click and call him. Or you can make meetings on Google Meet directly from the application. Okay? We are using, as a collaboration tools, Google, and we will use Google. But the idea is to have, to do not integrate what is already working, like Odoo or SAP or whatever it is, and fill the gap between what we would like to have to run the company and what is the base software that already exists in the middle. Salary, from my perspective, will be published. Transparency. Even the stocks. I spend 1 second more. I saw only to habilitate the chance that he can sell his stocks to him. But this looks to be too aggressive. No? Means I will buy back as a company instead than have a market. Otherwise, we will have a market like a football game. Too much. Let me say a little bit too much.
Okay, thank you very much.
Okay, thank you. But you can continue the discussion in the event. So we start the next talk in 3 minutes. Hello, everyone. So I ask everyone to accommodate for our next and last session from ICSOB. So I will give the words for the speakers so we don't lose time. So thank you.
Yeah, thanks for having us. Hello, everybody. My name is Finn.
And my name is Henning.
And we are pleased to provide you an impulse on the fundamental mechanism of digital transformation, and especially to give insights in how to manage the digital transformation in industrial companies. But first, let me introduce ourselves. We come from the University of Osnabrück in the northwestern part of Germany, and together with two other colleagues, we form the Digital Transformation Center of Excellence, and our mission is to drive the digital transformation in companies with scientifically based tools and methods. So we want to transfer our research outcomes to practitioners. So now we would like to show you the holistic and socio-technical understanding and mechanism of digital transformation. So fundamentally, it starts with the use of digital technologies. And when these digital technologies are capable of replacing previous technologies, then it comes to the so-called digital disruption in business environments. And these digital disruptions holds chances and risks for companies. So they initiate or require strategic reactions on a company level. And what is noticeable about it is that these strategic reactions are built again on the use of digital technology. So we have this circle of change. And when they use these digital technologies, the companies, there is a process of change within this company. And this change has a certain degree of impact. And when we talk about digital transformation, this is a change or the transformation which has the most far-reaching changes in all dimensions of a company. So like culture, competencies, structure, processes, but we come a little bit later to that. So we and other scientists say that this has a socio-technical and holistic character, this digital transformation, in contrast to just digitalization. This is just using technologies to improve processes, but this is far-reaching changes in the company. So there arises the question, how do organizations master this digital transformation, which is very, very complex? And we try to give an answer by presenting some steps for companies by using jigsaw analogy. Jigsaw analogy helps to achieve goals in life as it presents an idea process model. And this puzzling shows parallels to the management of digital transformation. So time and patience is required, discipline and motivation is needed, and there is joy when little parts come together.
Okay, thank you, Finn. Let's start puzzling what is needed. First of all, companies need to know what is the big picture. We have this question how is the vision of a digitally transformed organization? And maybe to derive a vision, companies need to organize all these puzzle pieces and turn them on the right side. So in reality, there's thousands and millions of puzzle pieces representing these opportunities, digital innovations, digital technology strategies, and how to deal with digital transformation. So companies need to identify the pieces that are really fitting to the company itself, and therefore they also need to analyze the status quo internally and externally, so really know what is fitting. When we know the opportunities and maybe derive the status quo, we need to start with the edge parts of the puzzle. So the edge parts in our example is the digital strategy. The digital strategy sets the boundaries for all the employees working in the company, so they know in which limits to operate. And the digital strategy also determines the structure and the direction of all the upcoming transformation projects. But the strategy doesn't have just one dimension. It concludes different, compromise different areas of action. And I will just briefly introduce you to them. In our research, we derived 5 different areas. It's the business model, it's technology and data, structure and process, it's culture and competencies. So these aspects reflect on the socio-technical perspective on digital change that Finn already mentioned. And if you want to be successful in transforming, you need to consider all of them. So this is something from one of our latest scientific publications. So we had these dimensions, and each of these dimensions has different characteristics. So for example, in the business model, you have to focus on customer value, include customers in product development, for example. You need partners to manage digital transformation. And of course, another example in technology and data, of course you need software, and free software can be one puzzle piece for that. Due to the time, if you want to see more of that, feel free to read our publication. There's everything in detail. So as we maybe all know, transformation won't happen from night to day, so it takes time. And in that case, transforming based on a single project has a great risk of failure. So you need to understand digital transformation as the sum of various projects. And these projects must be defined, they need to be prioritized because resources are limited, so you really need to be sure on what to start. And what could we do and on what projects can we start? In the best possible way, you pick the easy pieces of a puzzle, and you start with projects that are promising quick wins and can be used as some kind of lighthouse projects. So these lighthouses have a huge signal effect for upcoming projects and can help to build trust among the employees for digitalization or for digital transformation. As it takes time to transform, and can be years it takes, you sometimes have to step back a bit and review the progress you've did. So is it still in line with the vision we have, with the strategy and the goals? Or maybe do we need to adapt our strategy due to years of projects? And of course, all projects, all these single small projects need to somehow interlock and follow this great or this major goal, major strategy. And of course, we can check, okay, which puzzle pieces are missing, and these missing pieces will lead the way for upcoming projects. So if we are successful and finally finish the puzzle, what is it all about? So if companies manage to master digital transformation, they could possibly realize new business model, optimize processes, or improve the customer experience. And there are also other examples of it. But in reality, it's not that easy, so the puzzle is possibly never finished because there's always something new. There are new opportunities, new technologies that companies need to address and need to be aware of, and always be innovative, always be ready for change.
And so if you don't have a systematic approach or you deal digital transformation like a IT project, which happens a lot in companies, your puzzle looks like this one you can see on the slide. There are a lot of isolated IT projects, but it has no plan. It don't get to overall pictures. So lack of planning leads to failure at the end. So to keep in mind, in general, digital transformation is an interplay or interrelations of changes in every kind of dimensions, which has Henning presented, and this is what is characterized by digital transformation. So how do we provide support as application-oriented academics? We offer workshops or support in analyzing the status quo in a company, so digital maturity or the readiness for this transformation process. Then we help road mapping the way, the journey, by identifying transformation potentials and all these paths for transformation. And we support in the implementation of small lighthouse projects and keep them all together and try to support in the future. So if you're interested in our work and our research outcomes, please feel free to go to our publications, read them. We have the links embedded into the PDF file so you can reach them. Yeah. Thank you very much.
We have 3 minutes for questions. Any questions? Okay, I have one question. Let's say if you need to give one piece, only one thing important for a company that wants to start this journey, so what would be?
To have the big picture in your mind with all the potentials of digital technologies. This is a good starting point.
Okay.
And maybe I could add something. I think most companies are currently not taking the big picture and not are aware of digital transformation changing the whole company. It seems more like an IT project based on the IT unit and not maybe top management topic. It should be mostly sure for big companies. They're doing good with it, but especially like SMEs, they are currently having big struggles with it.
So do you think that will be like one of the, let's say, a very common mistake to don't have this big picture?
Yeah, definitely. And they starting maybe like, with new technology, okay, maybe I could automatize a few processes, but they doesn't make sure if it's really fitting to the overall strategy. So it's just maybe try and error, could work, but from our recommendations, I would say, before you're doing projects, think about the big picture.
Nice. We have.
It's a big question, but perhaps a quick tip for dealing with the cultural resistance of the employees in a company, especially the IT team that doesn't want to change the way to work and to change technology and approach to the technology.
So one recommendation is to have the big picture and have a roadmap, so you can share this roadmap to all the people. And if the people know where to go, where's the journey, where's the end of the journey, I guess this would reduce the resistance for some small transformation projects.
And I think digitalization is always connected, I think, to fear, like losing job or having to do something different in the job. And the projects we did with companies, it mostly comes down to the communication is missing, so maybe they inform a small unit, but all employees are exchanging, so they get to know it and they don't know, okay, what's going on, what does this mean for me? And we also had companies who have been good with it, and employees get that digitalization, digital transformation is there to maybe secure the jobs, especially maybe if you're getting in production or something like that. They're mostly fearing that the production line is going in a foreign country.
Okay, thank you very much. That was the last session of the ICSOB industry track, right? I hope you enjoy the next sessions of the SFSCon. Thank you.
Adesso? Ok. Allora. Okay. So we can start a new session. The first speaker is Mr. Gianluca Antonacci from CISMA SRL. He will introduce us their development on traffic management in a smart city scenario. Please.
So, good afternoon, everyone. In this talk, I will describe an application of a smart city platform. We worked on. It was conducted in the city of Crema, Region Lombardia, in collaboration with CIMET, which is the manager of public illumination and installation of sensor in the city of Crema. So a couple of words about smart city. What do we mean by smart city? We mean improving public services and life quality with data management and application developed on top of gathered data. In the last years, we have a focus on smart mobility, which is a subset of smart city application. And smart mobility means real-time traffic and secondary also air quality monitoring system coupled with real-time pollutant emission estimation. And we can use this approach in order to create data-driven decision-making support both for urban planning, which is long-term application, and also real-time traffic optimization and pollution control, which is a short-term application. So the presented work is indeed a proof of concept in a smart city, which is Crema, more or less 30,000 of inhabitants, and we exploited existing sensor and data streams, concatenating them and inserting also some additional features where necessary. I mean software features and pieces of software. The starting point was that we had traffic and air quality low-cost sensor installed in the city, newly installed. The problem or the issue was how do we fully exploit all this gathered data and estimate the local contribution of traffic on air pollution. That is, we have all this data, but we don't know what to do. And the proof of concept was putting together all this data stream, adding small pieces of software, and create value-added information and something elaborated, put in a database. The case study, as stated before, was in this small city of Lombardia, Crema. The application was on a 2-lane high-traffic carriageway in a commercial area, here in the photo, with more or less 15,000 vehicles per day, which is quite a lot in a small urban area. There are some traffic sensors based on radar technology on each lane installed, and also a couple of air quality sensors measuring PM10, that is particulate matter. So the starting point was that we had traffic data and air pollution gathered, and we wanted to estimate traffic emission from real-time traffic, and also estimate pollutant emission from car passing, that is NOx, which is nitrogen oxide, particulate matter, and also CO2. So in a couple of words, on a side we have pollution measured, we measure also traffic, and we try to estimate the correlation between these two data sets. So we had to implement a traffic and emission database, which is in future useful for support sustainable mobility planning. So user tools already Okay. Our tools were hardware, so install traffic sensor, measuring number of vehicles every 5 minutes on each lane. Then we had air quality sensor installed, and then we had to gather, I would say, static data set, which is or semi-static vehicle fleet composition, which we received them from Automobile Club Italia. That is the composition in terms of Euro classes and type of vehicle for that region. And it was used in order to estimate the composition of the fleet and the contribution to pollution. Then we used a software which is COPERT, which is the European standard for emission computation. COPERT is a free software. Well, the software itself is free but not open, but instead all the implementation, well, the standard is open, so you can rewrite it if you won't rely on the free software itself. And then we wrote some pieces of software, putting all together, and they were written with the software R, using SQLite as the database for storage, and to create API in order to export elaborated data. So let's have a look to fleet composition. So we have the 5 main classes in which we typically divide vehicle passing on the streets. So starting from the top left, heavy duty trucks, and here with the color we describe the fuel. Heavy duty trucks are typically all diesel powered motors. Then we have passenger cars, which are half and half petrol and diesel. Light commercial vehicles, which are mainly powered by diesel engines. And then buses, where there is also a little percentage of natural gas engines. And here the motorcycles, which are all petrol engine powered. Why we did this disaggregation? Because emission factors divided by Euro classes and fuel are quite different, and so we have to do weighted mean of the fleet composition in order to estimate a mean emission factor and correlate traffic transit with emission. Here we have a scheme of the real data processing system and storage. So we gather traffic sensor data and air quality sensor data each 5 minutes or 10 minutes, depending on the 2 streams, with an API which was given us by the manufacturer, with a quite standard API. We put them all in a database. We run an emission model, which is the one based on COPERT we spoke before. So every 5 minutes we have an estimate of the emission of nitrogen dioxide, PM10, and CO2 based on the traffic data. And then once a day we also calculate some daily statistics on how many cars have passed speed and calculated emission. We also have air quality, so directly measure pollution. Pollution is created by all the sources, not only traffic. So why are we doing all this calculation? Because we want to correlate the both data streams and estimate the percentage the contribution of traffic to the overall pollution. And at the end, we have an API which is exposing on the internet the total result and also the statistics. something on the hardware. So traffic sensor was based on radar motion detector technologies, which can detect vehicles up to 30 meters backward and forward direction, so in both lanes. It has an integrated signal processing and quite efficient interference suppression and vibration suppression. A drawback is that it has to be installed with a fine-tuning process, so the inclination is quite important in order to count correctly the vehicle passing. And for air pollution and air quality sensor, a low-cost air quality sensor based on laser scattering methodology was installed, and it gives us a concentration of PM1, PM2.5, and PM10. And so all this data are then available through an API in JSON format every 5 minutes. Well, this is the Copert algorithm. As I told before, there is also a free software which implements this, but it is conceptually very easy. So this emission factor is calculated on the basis of some coefficients depending on pollutant, vehicle class, fuel, year class, and the vehicle speed, which is measured by the radar. So we only have to do some multiplication and sum, or other way, use the free software from Emisia, and then we put all together, we calculate total emission, and we couple in the database with the traffic passing. So, and all this data were stored in a SQLite database, which is easily accessible in R language we used for all the statistics. So the raw data were traffic and air quality, processed data were traffic emissions, given in grams per kilometer for every vehicle category. And we also have daily statistics on traffic and air quality emission. That is informative statistics, for example, maximum, minimum, mean, standard deviation, daily sun, and so on, which can also be easily communicated to the public when exposed on the internet. Yes. Okay. Here we have also we also use the R code also to expose data through an API using some packages which are very handful and very well documented inside R. That is R SQLite to manage data in the database, Lubridate to manage time series, and Plumber, which automatically creates a web API, also using Swagger as a web interface, so an experienced user can create its single request via browser, and then do all the automatic requests are needed. So, for example, in this application, an experienced user can put inside this web form start data, end date, category, and clicking on get, it will export a JSON string with all the information. There is also an how-to for this web API we put on our Bitbucket repository, so that it can be explored. And this Plumber module of R was very useful for our application. Some results. These are some export in graphical form of the JSON strings of air pollution that is directly measured, and emission from traffic calculated. And so you see they are obviously not always coupled, because there is some difference which is given by meteorology, dispersion of the pollutant, and so on. And all this information can be used by public bodies in order to do long-term decision, and on the other hand, to do real-time application, for example, speed reduction or traffic deviation or so on. A couple of words about replication and scalability. So I would say there was a low replication effort because it can be all this work can be replicated quite easily because of we need a small implementation of small pieces of software in order to adapt to already existing data streams. And on scalability, I would say that it is easy to manage multiple nodes in the same location. Unique fleet composition for different nodes is if we are working in the same location. On the other hand, this is the only drawback, I would say, because we have different fleet composition moving from one region to the other or from one state to the other, and has to be repeated each time, unfortunately. We can move to the conclusion. So we have developed a real-time system coupling traffic and pollution in a small city, and it was a proof of concept of the smart city application. It provides both historical data collection and real-time data with two different purposes. That is, historical data can be useful to support urban planning, while real-time data, that is short-term, very real-time, can be used in order to manage traffic directly. Another point which is very important to me, it is often not necessary to build standalone solution, big standalone solution from the ground, from scratch, because they have high cost. But on the contrary, it is mainly cost-effective and time-saving to make most of existing features and create then value-added results. And to conclude, in my opinion, a modern smart application should have characteristics of modularity and easy exploitation of information towards the public, because the real sense of a smart city is gathering data, exploiting data, but communicating data to the end user. And that's all. And if you have any questions, I'm at disposition.
Please, we need a mic.
Do you have to present some data based on category of vehicle, for example? And one question, a second question is how can you trust the categorization of a vehicle which is going by?
Okay. So, well, I don't have here some. I don't have results on fleet emissions. We can say, based on this fleet composition diagram, that more or less, I would say 70% of the NOx emission in this city came from passenger cars, but obviously it depends on what you are measuring. It cannot be generalized. More or less 70% here, 20% here, and 10% here. These were negligible, more or less, in terms of emission. If we can trust classification, well, I wouldn't trust so much this radar classification. In this case, it was a low-cost sensor, and I would trust the total count, not the classification. But there are other models, well, higher-hand radar which can classify quite good vehicle passing.
So time is over for this presentation. We have now 5 minutes back, but I think we have another one. So this is the second speaker Roberto Monsorno from Eurex Research, Center for Sensing Solution. He will present the Hermes project and environmental pollution micromobility sensing application.
Thank you. Good afternoon from my side. Very nice to see many people. As introduced, I will speak about environmental pollution micromobility sensing, which is a short-term project, a technology transfer project implemented between three partners, us as Eurac Research as technology provider, Cyclopolis as the main, let's say, technology receiver and the entrepreneurship that does the micromobility sensing, and Gruppo FOS, that is yet another IT company that is located here in Bolzano and is in charge in this project of the productization of the prototype that now is something like this that is supposed to be mounted on the bikes. I think that I will shortly introduce what Eurac and Center Sensing Solution does in terms of open source technologies, not as a whole. Then I will speak about the problem, the air quality, air pollution, and how to monitor with micromobility. And then I will have this insight in the technology transfer experiment of Hermes, mainly focusing beside the goals and the expectation, but also on what are the components of open source that we are using for that project to bring and to show how the open source elements, components, architectures, and applications can really be placed in the real market. So, Center for Sensing Solution is a competence center located here in the technology park. We develop easy solution that enables the full data life cycle from sensor for acquiring data, organizing data, processing, analyzing, sharing, and then reacting on the real world. Our approach, data-driven approach, is mainly wondering to follow, sorry, it's too fast, is wondering really to follow the FAIR principle. That means findability, accessibility, interoperability, reusability, and mostly based on open source technologies. Let's talk a little bit about the problem. Here is some kind of even of sentence that is not directly my sentence, but also I would like to put some seconds here just to focus on what can be really a provocation, but also the problem. But what is really the issue around, I recognize that poor air quality is still a universal reality in several, maybe here, not here in the city of Bolzano, not that much at least, but really all around the world. And there are really addressed sustainable development goals that would like to solve this issue. Furthermore, there are really all around the world great examples on how through micromobility you can find clean air route. For example, this is an example of the city of London, and to reduce the exposure to air quality and therefore to gain in health while you are cycling around the city, for example. And for this purpose, let's say for air quality measuring, there are common air quality indexes that are really well defined. These are defined by the European Environmental Agency with the really specific values of several content of the air quality, PMs and ozone, NOx, SOx, and so on, as already explained. And there are really nice colored maps where you can see spots of, this is of some days ago, Monday. You see here in Italy or in the east of Europe, there are constant, not good quality hotspots. And here is where the experiment that I would like to speak about is introducing to map in cities through micromobility the air quality, in particular particulate matter, PM2.5, PM10, and the project has had this specific objective. First, improve the sensor. There was a sensor, there is still a prototype, quite heavy sensor, but really working, but we have to improve the battery life to make the robustness, and then, of course, we are also already designing the resizing and the pre-industrialization of this. But we have wondering to provide wide area network communication protocols, heterogeneous, multiple, let's say, and this is what we did now with LoRaWAN. In the next steps will be with other LTE communications to create the digital ecosystem and then to go for the productization. Today I will just focus here, but let me a little bit introduce what was really the status of where we started. We started from this sensor connected only Wi-Fi. Now the sensor has been made robust, more connected also through LoRaWAN, already collecting several data around the Athens city, but also here in our city of Bolzano. We extended it with this connectivity. The principle here is really taken by not my graphic, but was really easy to and well depicted. So there is a network of communication stations and any type of devices can be connected through these principal stations, and then everything can go through a network server. In our case, what is the overview of the architecture is that we used a network server that does specifically this kind of functionalities that has been implemented with CIRSP-TAC, that is one open source component that does really all the features of a network server. Then we created a middleware that after the registration of devices and the registration of the gateways can deliver sensor data in two ways, directly through an API that has been developed appositely for feeding InfluxDB, so actually the API is the API of InfluxDB, or creating a specific API that can really deliver the data in the database with the data structure and the data model that we want. All these components are the open source components that are really not difficult to be used, and with this specific nice open source project, a real-time system has been implemented. This is a schematic that represents really the two ways of bringing everything to the cloud, and actually then after the registration of the data into the databases, the data can be easily visualized through dashboard that it can be used yet through a open source component such as Grafana. I'm thinking that I will go really straightforward to the conclusion, showing some preliminary results. Let's say here, some really easy example. Here is some first test we did 1 month ago in Athens. While moving around the city, we can see that there are mainly good air quality. Then this is my driving back to Bolzano from airport to Bolzano, and you can see that here this side is quite more polluted than our, let's say, Adige Valley. That was really a nice thing to see. And of course, this is an easy dashboard, just set it up with few steps of configuration, no code is needed. Once the data are collected in one NoSQL database, then with some simple configuration, we can extract everything and put in, let's say, at the attention of the citizens. At the end, of course, here we will like to work much more to represent the data in a better, fancy way to enable also citizens to understand better where they would like or they could move without expecting damages on their health. So with this, I'm already done, I guess. The last slide brings us to what are the expected results. We would like to really improve the quantity and the quality and the availability of air quality information and data for cities, and we would like also to raise awareness for air pollution and to move citizens, guests, tourists, moving safely in any city. So thank you for your attention, and I guess there is some room for questions. So thank you very much.
Thank you, Roberto. I know for sure there is one question, and then we have some time for further questions later on.
Yeah, congratulations for the presentation. My question is, how precise are those sensors, and does the speed affect the measurement of the data?
Oh, thank you for the good questions. Honestly, for the first one, the sensor is a low-cost sensor, the air quality one, but the choice has been already done by Cyclopolis based on the inputs that this company from Athens was receiving by the National Observatory of Athens, that is in a way the environmental agency of Greece. And they did already a validation campaign, and they are going to do even more validation campaign for the specific sensor that is embedded in this system. Concerning the influence of the speed, actually when we had the chance to install the sensor in Athens, we had a nice talk with this National Observatory of Athens, and their statement from scientific point of view of air quality or even environmental scientist perspective say that the speed that is going to be not more than 25-30 kilometers does not affect the measurement. So since it is supposed to be on bicycles and that we are not that fast, unless you are not a champion like you, whatever, we can really rely on the measurement that are not affected at least at that low speeds.
So the sensor couldn't be mounted on a car?
Let's say in that case, we should consider, according with the domain expert, what can be the correction factor that we might apply in post-processing or in real time. You know that we are approaching this low-cost sensor also with artificial intelligence models and algorithms that can correct on the fly the information, but this could be further consideration. But of course, the same sensor has been developed to be mounted on micromobility, so then you can map really large areas, but this could be also, since it's quite low cost, we can also consider this kind of sensor be used to be static and located in your home place. I have one similar sensor in my balcony, for example, belonging to a wide community of sensors that is the Luftdaten community, that are really cheap, almost calibrated, but still they give a good information for a large, let's say, mapping of any kind of parameters. Of course, they have not the same value like the sensor validated and certified by the environmental agency.
Thank you.
Thank you.
Is there any other question? Otherwise, I have a question. I know you also worked in other projects where some of these weather station moved across the city. I wonder if you tried to, or you imagine that one day maybe some bicycle or a lot of bicycle can travel in the city center or outside the city center and push data of like environmental data to common platform or open platform or open data sets.
No, indeed, this is exactly what we are considering to do already in this project.
Okay.
So the data can be real-time pushed whenever there is connectivity inside the city, for example, with different communication protocols. But we demonstrated, for example, this trip that I did from the Bergamo to Bolzano, the sensor was working offline, and then when reached the connectivity, like my office,
Okay.
There was a dump, there is a buffer here, and these data are supposed to be, then we have to find the agreement, and there are partners that are not only me as a decision maker, but all this system has been collected in a open source system with APIs available. So whenever they are open, at the end, I guess that they also can end up to the Open Data Hub, for example.
Thank you, Roberto.
Thank you to you.
So we have now 5 minutes back. Introduce our next speaker. It's Anton. He's Anton Dignus from Free University of Bolzano. He will introduce us how can be managed the temporal data series in PostgreSQL. So please, Anton.
Thanks for the introduction. Okay. Okay, so let me introduce you a little bit about temporal data, how we can store and manage temporal data in Postgres. Wrong one? Correct one. Okay, so first of all, temporal data can be found in many application domains, like in HR departments, in insurance, in the insurance domain, in the tourism domain, in the medical domain, stock market data. So all in these domains, we have basically data which is changing over time. And what is temporal data? So temporal data is basically data which has a timestamp, whatever that timestamp is, we'll see in a minute. And the timestamp of this data indicates when the data is valid. So this is what we consider temporal data. So examples are basically contracts with a validity period, so we know when this contract was valid, sensor reading with a measurement time, error events, and when these events happened. Okay. So Postgres introduces, for the data type time and timestamp, introduces some basic utilities. So we have a date and time data types, and whoever worked with our calendar system, our calendar is very irregular. We have 7 days a week, some months have more days, some months have less days, and so on. So this is basically an utility that is provided by Postgres that implements a calendar system. But today it's not about storing date as a data type, but it's about temporal data. So as temporal data, we basically identified two different types. One is period temporal data and one is time series data. So in period temporal data, for example, your data is annotated with a time period, a starting point and an ending point. If you have products and your product have prices and the prices change over time, so you might have basically a price with a starting point and an end point. And later on, the price changes, so basically you have a new price for this product. Okay. And the other type of data is time. Oh, sorry. Is time series data, and this is what we heard before, which is basically sensor reading, measurements that are basically measurements of a continuous signal over time. So what we do today is basically to have a small peek what Postgres has to offer to basically store and manage such data. So in terms of period data, so now we are talking basically about data which has a start and an end time. Postgres provides so-called range types, which is basically a data type that lets you store time periods. Okay? So you can basically annotate your data with one of these range types, and Postgres provides you a lot of different functionality together with this data type. So just to give you a quick example, so here everything is basically a default, let's say, creating a table in a database. And there is one special thing which Postgres allows you to do is basically declare one of your data records as a date range. And the date range means this attribute has a starting point and an ending point. So here we see an example of products with prices. And what you can do is basically you can store your data in such a way so that every of your product price has basically a starting point and an ending point. Okay? So this is basically a capability that Postgres provides you to store start and ending points together with your data. Together with this data type, you get a lot of predicates and functions. So if you have prices which are changing over time, one functionality that you might want to have is basically what was the price at one of these particular dates. Okay? Postgres allows you basically to go back in time and look for that price. Or what were the prices, the previous prices of products. Okay? So you have a lot of functionality which basically is offered by Postgres, which allows you to do this querying capability. One more thing which is very important, if you store prices with start and end dates and your prices are changing over time, You don't want to have two different prices for the same product, right? So what Postgres additionally allows you to do for such kind of data is basically do exclusion constraints, which adds a particular syntax, where you disallow for the same product different prices. Okay? So it allows you to specify integrity constraints that does not allow you to insert two different prices at the same time. Okay? So you can have some constraints there. If you try to do so, it will basically tell you, okay, there's a conflicting value for the price of one particular product. So just for you, since this is just a small peek about these types, so what are the take-home messages here? So if you store period temporal data, use the range types. These are the native data types in Postgres. It's very convenient. It really simplifies your business logic because you don't have to do that in your application, but you can directly use database functionality. It's very convenient. You also have indices available over this temporal data, which allows you basically to speed up your querying. And there are some constraints which you can basically use to avoid inconsistency of the data at the source. And you don't have to do it in your business logic or your application. Okay, so this was basically about period temporal data, so where data has a start and an end time. And now we move on to time series data. So how can we store time series data in Postgres? So there is an extension which is called TimescaleDB, which you can basically install on top of Postgres. TimescaleDB is an extension, so basically what it does, it exploits all the extensibility of Postgres and implements additional functions on top. So when you write queries, you can basically use additional functions which are provided by TimescaleDB. It runs on a server side and is basically available for most platforms, on which you can also run Postgres. Okay, so what does TimescaleDB give you? It gives you basically 3 additional features together with all the features that you have in Postgres. It gives you hyperfunctions, hypertable, and it allows to compress the data. Hyperfunctions are basically additional functionalities, so you can have additional functionality on top of everything that is available in Postgres. Hypertables are there to basically improve performance, less access to data, and compression makes data smaller, which also basically improves performance at the same time. There's a long list of functions. I'll just show you one, how to use it within a query. So here we basically have a query, and there are 2 components here that basically TimescaleDB provides you. So one is this function here, time bucket gap fill, and interpolate. So what we do here is basically we have sensor. Sensors sometimes have missing data. So what we want to do is basically we want to interpolate missing data right in the database. Okay? So what we can do is basically we can tell the system do a gap filling for every 5 minutes. Okay? In case there is missing data, interpolate it using the average function. Okay? And what you get is basically data every 5 minutes out of your sensor readings. In case there is missing data, this function provided by TimescaleDB will impute it for you, using in this case linear interpolation. Okay? So it will just use the previous value and the next value and basically do an interpolation of that. Okay? So this is an additional function which is provided to you. All of the rest of this query is just traditional SQL. It's just these 2 functions which are provided by Timescale, which basically allow you to do additional querying capabilities. Hypertables is the next feature that TimescaleDB provides you, and this is basically to improve performance. It's not additional functionality, just to improve the performance. So it's again function-based, and what it allows you to do is to break up the data that you have, the time series data that you have, into smaller pieces. So when you do querying, you touch less data. And again, this is done with a function that, again, TimescaleDB provides you. You have
a relation already in your database, and out of that relation you can create a hyper table, which basically creates many smaller tables. Okay? But you will not see anything of that when you do querying. The system will do everything for you. It is just basically transparent to you. There is one thing which we have to be careful when we do this kind of partitioning. The partitioning is somehow a user-defined parameter by us. Okay? So we tell when and how to partition. So in some cases, and this also happened to us, if you have a lot of data, so for example, data over 3 years, we have 100 sensors, and we pick the parameters kind of wrong in the when creating the hypertables, we might end up with many tables. Okay? If we are looking for data, in some cases we might have to access 1/3 of these tables, which means like we have 7,800 tables in this small example. It's not a lot of data. And we have to access 1/3 of these tables, which costs a lot of time. So, and sometimes accessing those tables is more expensive than just accessing the data. Okay? So, it's just to say, be careful when you do partitioning. You have to be somehow, you have to think twice about that. Okay, compression is just yet another feature that it provides you, making data smaller. So it's again done by using functions. You apply a function and the system will basically compress the data for you, and you will not even see it from the outside. You just do regular SQL, and timescale.db will basically compress and decompress the data for you on demand. Yep. Okay, so just the take-home messages maybe for timescale.db. So what you do is using regular SQL in Postgres. Timescale.db will basically handle the rest. Plus you have additional functionality in the form of these hyperfunctions, which are very convenient functions. You can use hypertables to somehow improve the performance, but you have to be careful to not destroy it on the other side by doing too many partitions. And compression, which basically from our point of view or from our experiments usually improve the performance, because having data smaller means you have to access less data when you do querying. Okay, so just a few words on what we are working on and why I bring this up here as well. So we have 2 projects, one which is basically on period temporal data that we saw at the beginning, and the other one is about time series data. And what we try to do is basically we try to work with the features that we have available in Postgres, and in both cases try to improve them. So for period temporal data, what we try to do is to add additional constraints, just as we saw before, where we could not have basically 2 prices at the same time. So we try to basically improve the constraint check that we can do in Postgres, and also to look for basically anomalies in the data, which having 2 prices at the same time would be a kind of anomaly in the data. We try to provide capabilities basically that try to find these kind of anomalies. In terms of time series data, we are working on predictive maintenance, where we use this timescale.db, and we did some experience with it. And basically in the future, what we try to do is we try to also improve the features there, particularly the partitioning, which is very user-guided, and we try to make it a little bit more automatic so that you can't do that many mistakes basically when you do the partitioning. And yeah, was a lot of stuff, sorry for that, but it was just 15 minutes, so yeah, thank you.
So thank you, Anton. Are there any question on this tool and the instruments? Maybe some of you have some application or timescale.db or PostgreSQL to this type of data, please.
Thanks. Yeah, thanks, Anton, for the interesting talk. We're also dealing with databases in time series, and yeah, I think the functions that you mentioned that do directly the interpolation on the server side is quite interesting. And now you mentioned average, but are there custom functions also possible So not only using an average, but maybe also inserting NAs by default.
Yeah, here I didn't go into detail in the query. It was already a lot, I think, providing the query. So what happens here is basically linear interpolation. So the average was basically used to, if you have data every 10 seconds, what you do here is basically you aggregate this data using the average functions on 5 minutes buckets. If you don't have data, then you try to interpolate. So there are few interpolation functions, but what is mostly used is basically the linear interpolation in this case. So there are not arbitrarily complex functions, there are the basic utilities, but there isn't, let's say, a lot more at the moment. The function keep on extending and they keep on improving every time, but yeah, at the moment, they are just the basic ones. Mm-hmm.
Thank you, Anton. So we have now 5 minutes break. next speaker is Peter Sellner of HERC Research Institute for Earth Observation. Peter, you will introduce this Alpine Drought Observatory platform, and in particular the CI/CD pipeline, and how it works from operational data to web-based visualization. Please.
Yeah, thank you very much for the introduction, and hi everybody. Today I will present a project that was sponsored by the Interact Alpine Space Program from the European Union. So we were a consortium of different countries around the Alpine Arc and trying to set up a Alpine monitoring system for droughts. And our part at EURAC was to set up an observatory platform on the web that is Alpine-wide and is operationally updating itself on a daily basis. So that was kind of our goal, and you see we have a lot of contributors here since we were quite a lot of people dealing with this question. So here again, just a general overview of the Alpine Drought Observatory. So this is a problem, you've probably heard it on the news, and our part was setting up this web platform with working together with different researchers, biologists, remote sensing experts, meteorologists, and so on. The outline of the talk today is, what is the web platform made up from? So we have, we thought about how to design a platform. We need an infrastructure to do daily processing, to do downloading, all that kind of things. We somehow need to operationalize that. So we need a system for that. Then we have a web portal and also, say, a raster database where you can do more elaborated analysis with the data. Then we will show the available data we have, and also what is important, the metadata and citation to make all this a fair process. So generally we're going from the science part, where some researchers come up with code, maybe giving the mean of the temperature as an easy example. Then we port it, they produce data, we put this code into production and then go into dissemination all in one hand, and we're using exclusively open source solutions and try to be as fair as possible for the data access. So the ADO web platform, this is what it's made of. At the heart is this web platform, which is an interactive map. Unfortunately, we cannot do a live demo today, but we have the links later. Yeah, and as I said, it's made up of a production system that is based mostly on Docker containers, the GitLab CI/CD processing chains, and the Kubernetes cluster who is orchestrating the Docker containers. Then we have all the data that is coming out in a storage system, let's say the raw data that we are creating there. We have an access mechanism that is on the one hand Rasterman, which is a raster database or open data cube, so raster cubes. Then OpenIO is an API to interact with them, to slice and dice the data. And we have the environmental data platform that is also has been invented by EURAC and the CSS team from where Roberto has been talking before to enter this data publicly. And also the metadata, we have fact sheets, we're using the stack catalog, which is the standard for spatiotemporal data. And we can issue DOIs so that our data has a digital object identifier. Yeah, and as said, this is making our data as fair as possible. The design phase, so we knew from the beginning we have different users. On the one hand, we have scientists that are experts users. They don't want the data on an aggregated level. They want the raw data. Maybe they want to do processing. They want to calculate the indices a little bit different, want to combine them, and so on. On the other hand, we have journalists, we have decision makers. They don't need this granularity and probably don't have the competences to use the tools with it. So there we are having a simple map with nice visualizations that everybody can understand. That was our idea. The infrastructure is not so important. What is more important now is that we have everything on our GitLab instance. So we have been collaborating with researchers from Austria, from Slovenia, from Romania. So you see the partners below here. And yeah, that has worked nicely in a collaborative way. And the important thing is that they have prototyped the code on our VMs, so they accessed, they tested, downloaded data. How can we do this? How can we come up with relevant drought indices, like the greenness or yellowness of vegetation, or the amount of water that is missing? And then they have given these codes to us, and we have packed their code into Docker containers. Then we have set up a CI/CD pipeline that is triggering, after one process is finished, is triggering the next process. So if, for example, the download is done, then the next step starts automatically. And then that is running on a Kubernetes cluster. And in the end, we also have Docker containers that push that into a database. The time series database that has just been mentioned would have been an asset for us in that case. Yeah. And then we can directly push it also via GitLab to the web portal. So here you see a little bit the complexity of these indices that we calculate. So we download climate data, we download satellite data, then we have to downscale this to different resolutions, make this all interoperable so that in the end everything is on the same grid, and you can say, okay, this now I have the temperature, but I also maybe want to see the greenness of the vegetation, so it has to be on the same grid and accessible in one data cube structure, let's say. Yeah, and so on, and in the end, as said, we're going into the ADO portal update database, and then we're pushing it to the web portal, or we're pushing it to the open data cube, accessible through the environmental data platform. Here a little bit more detail about the pipeline operations. As said, this is a cascading system. So the download starts, then we're going into the next iteration of processes that are going to start. And so here all these pipelines, they are starting, for example, on a daily basis, and then the cascading system starts, and we also somehow need to monitor this. That is important so that we don't get gaps in the time series, and there's the system that we receive a mail if one of the pipelines fails, for example. Here's the list of indices. It's probably not so important since this is not a domain research conference, but yeah, you see they're quite plentiful. We're going through precipitation anomalies, standardized precipitation, evapotranspiration, the soil moisture anomalies, the vegetation indices, snowpack indices, and hydrological station measurements. So it's not only, let's say, raster data, but also point data that we're dealing with. Yeah, here it is on the Rasterman backend that you can access with web services. Then, as said, we have this whole database of hydrological stations that are downloaded automatically and update the time series. So that is also a whole project in itself, actually. Additionally to that, we don't only get the data, we also look into impacts. So that is text-based data. So there are people going through newspapers and looking, okay, there has been a drought. What does this actually mean? Is it an agricultural drought? Do we have money loss? Do we have to cut the grass earlier or later? So these kind of things, that is also everything in a database and available on the platform, as you will see. And then, of course, we have the metadata as said, and we are trying to follow the standards as far as possible. So the spatio-temporal asset catalog, for example, that makes it possible that we don't only have the data available on the environmental data platform, but because we have chosen this standard, it is also findable through, for example, GEOS, which is the Earth Observation System of Systems. So also other platforms can harvest this data directly without any interference. And we can issue DOIs for all of these data sets so that if somebody wants to use them, for example, in a scientific publication, they can also cite them back. Here's now an image of the web platform. Is it a PowerPointer? Yeah, so theoretically this is interactive, so you can go back in time and see how the drought situation changes over time. Here, down here, you can change the indices. These are the NUTS levels, so the aggregated raster data, and if you click on one of these NUTS levels, you will arrive at a time series so that you see how has this data changed over time. Then you can blend the different indices also here, so to see if they are behaving similarly, or maybe a vegetation drought is not occurring at the same time as a soil moisture drought. Then at the same time you can change here to the impacts, and then you get, when you click on a NUTS region, you get this newspaper archive that will tell you which impact category it is. So as said, agricultural drought or whatever, and you get a small abstract of this drought, and so you can see which conditions provoke which kind of drought, and you can, like that, maybe do some expert-based estimations into the future. You can see maybe early what this will mean. Here's the hydrological part. So we have also the gauging stations that give river flow information that you can also include into this analysis, and this is all interactive dashboard. So the conclusion is, we have fair data principles. We're combining many relevant data sources. Different user groups can interact with the system. The portal is more or less fully operational. Some hiccups now and then, but we're giving our best. And the framework is now a blueprint also for other drought monitoring platforms. So all the regional drought observatories around Europe are going to use this framework across the European Union. And it's completely open source, deployable in other institutes, regions, countries. And I said it was a great collaboration from scientists and more technical people in different countries. So that's it. If you're interested, here are the links. You can check out the platform anytime you want.
Well, thank you, Peter. Maybe do you have any question? I have one. Maybe it's about the next steps more than the current project. So I wonder if if you can tell us how complex would be to do a forecasting based on this type of information that you already can collect and aggregate.
So you're interested in predicting the future, like in a forecasting system, more or less?
Yeah, based on this type of...
I would say that's still a research topic.
Okay.
And since drought is such a complex topic, all the interactions that happen are really difficult to understand, even when you're doing it in hindcasting. It is hard to understand which meteorological system affects what, how is the snow affecting the drought, how is the vegetation affected, is it only a groundwater drought? So it's a really difficult topic, and I wouldn't say that you can predict it, or at least it's a really cutting-edge research topic, if so. So nothing that would be put into operationalization.
Then we still have 3 minutes. I also have another question. I'm not fully an IT man, but anyway, I wonder if you plan, or if you already had a pipeline for evaluating the quality of the data sets once you are updating them.
Yeah, that's a good point. Yeah, logging the quality of the data and also checking the quality of the data is of course important when you do something operationally, because if you don't check it, you will publish, in the worst case, garbage. So what we have come up with so far, at least we're checking that the values are in the correct ranges. We're checking for missing data. But let's say a real validation, it depends on how the researchers have provided their code. So if they have a good validation system within their code, then it is there already. But additionally, we haven't worked on it. But there has been a long phase in the project that was there explicitly for designing these indices and checking that they are coherent with what has happened since 1980 or 1978 up to now. So there should be actually sound scientific methods that are not also at the latest cutting edge. That is more that we provide them now and make them accessible.
Okay. So thank you. We have now, if there are no questions, we have slightly longer break than before, but more or less 5 minutes. Thank you, Peter.
Thank you.
So our next speaker is Francesco Corcoglioniti from Free University of Bolzano. He will introduce us a quite complex topic, probably, but it's about integrating dynamically computed data and web APIs into virtual databases and knowledge graphs.
Yes. So, thank you everyone for being here and attending. So it's a long title, but basically the idea is the following, is how to access APIs along with other data in a setting where the API is accessed through a virtual database or a virtual knowledge graph. So the overall goal is to facilitate the access to these APIs. Okay, I lost the presentation. Okay. So, a bit of background. I don't think I have to tell you how important are APIs nowadays. Here we are focusing on, let's say, data-related and data-intensive APIs, so these APIs through which you can gain access to data sources. And they are very frequent because nowadays many data sets are available through APIs. And a typical problem that you have if you build an application using these APIs is that your application has on one side its own data sources, yes, sorry, and it also needs to access data from the APIs, so it has to orchestrate these two kind of accesses by itself, and this may be complex. And what we would like to do is to try to have a unified access through the virtual paradigm for knowledge graphs or databases in order to facilitate this kind of access. Now, just an example before moving on. Let's assume that we have a setting with one database. Here I use the Open Data Hub database where we have data from the South Tyrol area about tourism, accommodations, so on and so forth, along with a semantic search API. So we may have a simple query like give me all the accommodations, all the hotels that have, let's say, the rating is 3 stars or more. This is a so-called structured constraint. So we will look at a particular property of my entity, and I want this property to match a crisp constraint. And also I want another kind of constraint, a text constraint, where I say the description should match some text keyword query, okay? And for this part, we want to use an API. I know that in principle with some databases you can have some text search, full search facilities, but here we are, let's say, interested in semantic search where you want to use techniques where you look at the overall meaning of the text that the user entered and you go beyond pure term matching. But really, this is an example. You could have used other, let's say, APIs for getting temperature data, weather data, so on and so forth. Okay. Now, this is what we want to do. So you have the application, you have the two sources, the API and your database, and we want to look to access these sources if they are a unified virtual database or a unified virtual knowledge graph. So the data model is different. Here is a relational data model. Here is a graph data model, and therefore also the languages, the formalism you use to access them, they are different. So we may use SQL to ask a query over this virtual database, or Sparkle, which is a standard language for accessing knowledge graphs of RDF data. Okay. And the point is, if we provide access to these data sources in a unified way, then this should facilitate the application in accessing them. Keep in mind that this database or knowledge graph is virtual in the sense that we are not going to put all the data, materialize it into a single location, but we keep the data in the sources and we access them at query time. And therefore, we operate in a data federation setting because each source is separate and we need to access them jointly. So we start from some operation like a query, and this query has to be routed to the different sources. How? We have to split it in subqueries and the subquery to the sources. Now, I will start, from the first side, virtual databases, and then on top of them I will address the virtual knowledge graph setting. Now, for virtual databases, let's start from what is there. So we have a standard, an extension of SQL, which is known as SQL-MED, Management of External Data, that allows us to define virtual databases as the union of schemas from different sources. So here in this case, I'm defining a virtual database as the union of a database that I access through Postgres, the Postgres wrapper. So this is a Postgres database with a particular connector. And then there is a service source that I access through this service wrapper, which is the one we are developing. So this provides us access to an API as if it is, let's say, a relational source. After I do this, I have this database virtual with the two sources. From the Postgres source, I can import the schema because you know databases export the metadata. From the API, I cannot because there is no such metadata unless we consider Open API or this kind of stuff. So I have to define what are the tables that form the, let's say, provide a relational view over the API. How we do that? We do that through a simple solution we developed, which is the one of API bindings. Now I give you the intuition for that. We start by mapping the operations of the API as procedures of the database. So a procedure takes, let's say, a tuple of parameters in input and produces a table. So tuples in output. Here, for example, we take a query, which is a string, and we produce in output tuples that are the query itself, the identifier of the accommodation that was matched, the score of the match, and an excerpt that tells us which particular piece of text was matched. How we do the mapping? Well, we have some metadata here that tell us that in order to call this procedure, which is backed by an API call, I have to do a post to a specific URL with a certain body, and then at the output, I have to interpret it with this template. Okay. After we do that with all the API operations, then we map them to virtual tables. So here, for instance, I have a table for the matches of this semantic search API. And I say that if I do a select operation over this virtual table, what I have to do in order to do this select is to call this procedure. So when I do select star from VT sem search match where query equal to something, I'm actually calling this procedure. So this is the intuition behind this mapping. Of course, I can do it not just for select, but also for insertion, update, upsert, the combination of the two, deletions. So here this table is the one where we index the data. So we have the identifier and the piece of text we are indexing in the database. Now, when we do that, trust me, the system is able, since it sees tables from different sources, given a query that in this case captures this, give me all the accommodations that match horse riding as the search, it can produce a query plan with two, let's say, subqueries. One goes to the API, one goes to the relational database, and then you have the usual operations of relational algebra where you combine the results. Now, this stuff can be optimized, so it's better if you optimize it in order to get proper performances. So a first thing you may do is to push down to the API all possible relational operations that can be pushed down. So if the API performs filtering, so you know query parameter equal to value, then it's better if you exploit this capability. If it gives you slicing, by slicing I can also say pagination, so give me the first page of 10 results, then okay, instead of evaluating the limit myself, I will send it to the API. So this is something that we implemented for this connector. Another thing that we may exploit are these bulk accesses, bulk operations. So think about an operation of the API where we supply, let's say, give me all the accommodations with these identifiers, identifier 10, 12, 42, 43. In a single call, I get all the objects that match these identifiers. If we have such bulk capabilities, better to use it. Why? Oh, sorry. Because we are going to reduce the number of API calls. And especially in the context of some operations like so-called dependent joins. Here, just to give you the intuition, imagine I have to join the two tables. One is backed by the API, the other one by the database on this condition. So this attribute here is equal to this attribute there. I start calling the database because it's less expensive. I get all the possible values of attribute A, A1, A2, A3, and then I do a bulk operation. Give me all the tuples from the API where this attribute is in A1, A2, A3, so on. So this is faster, and this is something that is being done by federation engines. So it's important to expose this capability when we build this wrapper for APIs. Okay, then some APIs we know are expensive to call, so you want to materialize them before. Okay, it's a scenario that we have to consider. So for this, we have to also account for materialization techniques. And you can do that by using materialized views. Okay, we have also a solution where we can, let's say, we have a specialized materialization engine that is more flexible for doing that. So basically, we have rules where we say materialize this table by executing this query. So this is the virtual table for the semantic search engine, and the result of this is that we are populating the engine. Now, these rules may have relations because one materializes a table that then is used to materialize another one. So the execution of them has to account for dependencies, and based on the dependencies that we mine, we can compute an execution plan. So these are details. Okay. Now that I told you about the virtual database setting, we may think about putting on top of them a virtual knowledge graph. Now, I will go quickly on this. In this virtual knowledge graph setting, we start with a query on the virtual knowledge graph, let's say a Sparkle query. The idea is that we rewrite it according to an ontology to account for what can be inferred, let's say, from the ontology, like a subclass relation. So I ask for all the accommodation, and then I have the hotel, which is an accommodation. So my query becomes, give me all the accommodation, union, give me all the hotels. So this kind of consequences. Then after we do that, we exploit mappings to the data sources to rewrite to an SQL query, which is asked to the data source, and then we get the result and convert them back to the result of the query over the virtual knowledge graph. Now, here we have our virtual database, which also integrates the API. So the setup is straightforward, although we are still working about optimizing it. And in this setup, here is just an example where we have an ontology, we have the mappings. Now, what is different is that in the ontology, we also cover the things that comes from the API, and in the mapping, we also cover the data that comes from the API itself. After we do that, trust me, in the sense that you can start from a query over the virtual knowledge graph, a Sparkle query. This is translated, in our case, using OnTop, which is a virtual knowledge graph engine we are developing here. In my institution and in OnTopic, we translate it to an SQL query. This SQL query then is over the virtual database, and then using the techniques I told you before, it is translated on something that can be executed over the API. So here is just a demo that I don't have time to do, but if you go to this URL, you can try this, give me all the accommodation that match this horse riding criterion, and the rating is greater than. And they have also a nice graphical depiction of it. So to conclude, this is the overall setting, where we start from sources that are either databases or APIs. We have a way to combine them together in a virtual database. How? Using API bindings and then materialization rules for expensive operations. On top of them, using regular virtual knowledge graph technology, we can put a virtual knowledge graph. We know that there are optimization, let's say, opportunities, because the virtual knowledge graph is over something that is itself virtual, and we are looking into that. So this is part of, let's say, the future work. Okay. And then we have other directions we are pursuing. So that's all. Here are some links. Thank you very much.
Thank you, Francesco. We have 1 minute for one question. If there are no questions, I saw the last slide you were mentioning a project. This one, maybe you can just give an overview in 30 seconds about this one.
Yes. Let's say there is an increasingly frequent request, which is about analyzing data that is not just captured by database, but also comes from APIs in the scope of different kind of domains. Here we have a domain that is about climate risk management. You have data that is static, but then you want also to do some analysis, simulations over this data, like what happens if I do some, let's say, kind of intervention in a particular setting, and then you have maybe to evaluate a machine learning model given some input that produces some output. The idea is you take these models, you wrap them into an API, and then you can use exactly these techniques where the analyst will ask a Sparkle query, and then it will transparently call both the API and query the database.
Thank you, Francesco.
Okay. Thank you.
Yeah. Now we have a small break, 5 minutes. So now it's time for the next speaker, and yeah, it's he's Peter Hofgartner from On Topic. He will introduce us how to bridge the gap between BIM information and GIS distributed information. With open source software. Thank you.
Okay. Hello, fine, I'm Peter. Pleased to meet you all. Have it. Okay, there's an Italian saying that says traduttore traditore. So it's usually impossible to translate something exactly without loss of meaning. So basically, as human language and even computer systems will see that it stays true for a long part. Let's talk about building information modeling. What's a BIM? BIM basically is a digital twin of a real construction work. This is usually construction work might be a building or can also be a bridge or infrastructure or many kind of things. what's in that digital twin? There's a lot of information in there. There's most of all the geometry, but not like a CAD drawing where a line is a line and human imagination can imagine that might be a wall because that makes sense, it's a wall. In the BIM, a wall is really defined as a wall, and the door is defined in which wall that door is, so you have really real objects with real meaning in there. You can place set geometries, you can place more information there. For example, the whole construction of the building can be mapped there. You have all the project plan there if you want. You can have the whole maintenance plan in that file. You can have really almost everything that's related to that building or to that infrastructure. As said, there might be also more calculation work. You can have all the structural analysis there. You can have all the energy balance of the building. So basically, digital twin of construction work is BIM, so with infinite amount of details. Basically, there are most historic companies who did architectural CAD programs switched over to providing software for doing BIM, because there's also a large requirement by most public bodies that you have to deliver all your planning work as a BIM file. All the construction world is moving over to that. Obviously, each software has its own very specific format, so ArchiCAD or but what's the company of Autodesk? Autodesk has its Revit, and other companies have their software. But there's an exchange format between different BIM software, and that's called IFC. IFC stands for Industrial Foundation Classes, and there are 3 different variants of that, but the object model behind is always the same model. You have either the representation as an XML file, or as RDF, which is let's say the formalism of the semantic web, and then you have text files. From what I have seen, basically the text file is really the predominant. I've never seen in real life anything else than the text IFC file. It's quite legible, it's not so bad. You can have okay, it looks scary at first sight, but everything has a meaning. So a geometry is defined as a geometry, a pipe is defined as a pipe, a wall is an IFC wall, etc. So with a little bit of time, you get into it, and it's not super hard to parse. Then, if you have the right software fit, then you can even view the whole thing. I guess there's quite some people more related to open source. So basically, cool thing is that most of these BIM viewers, they run fine under Wine. I tested them, and I put them in the app repository of Wine, declared them as 5-star because they run very well. There's some open source software that's able to visualize them. For example, there's FreeCAD, there's Blender BIM, but usually people working professionally with BIM, they have their commercial software because there's not really a competitive open source software to create those files. In addition to buildings, you can also have infrastructure. That's the thing that we are more interested today. This one is the distribution of water, drinking water network at Merano. Merano is my hometown. And the whole project in some way is related to Merano because the thing that the prototype was placed there. And what is the big difference now from BIM to GIS? As we said, BIM is a whole lot of details. GIS is different. One thing that, from an open source perspective, one of the big differences that for GIS you have really a lot of software and a lot of professional people work with open source software. You have a huge lot of file formats. Those file formats are super well documented. You have a very well-organized standardization body, which is the Open Geospatial Consortium that specifies all the file formats. So the open source world looks very good in GIS. As I said, GIS was born out from the defense sector, out from the environment sector, out from the agricultural sector, and is used mostly for land planning and everything that's related to the territory. As I said, it's large scale. In GIS, you usually talk about countries, about municipalities, about the whole earth. Whereas in BIM, we talk about smaller things, buildings, maybe some districts, but not much more. As said, we have strong standardization, high acceptance about open source solutions for that. And one of the things that's particularly relevant to us is that we, as you heard already before, Francesco mentioned Sparkle. He mentioned knowledge graphs. He mentioned virtual knowledge graphs. The thing that we wanted to have in the end was something that you can query with GeoSparkle, so the Sparkle language with some geographical extensions. So just to compare the two, as said, one is more for larger scale, the other one is for smaller scale. One has a lot of details, the other is more essential. One has more open source support, the other less support. That's more or less comparing them. So now we want to bring, the basic idea was, okay, we have now those super complex BIM files, an IFC with huge tons amounts of details. Can we reuse the same file for doing something that's more related to GIS, for example, for network analysis and those kind of things? And the naive answering would be, yeah, I have a lot of information, I take away some information, then I have what I want. People might be smiling because people knowing those kind of things usually are not that trivial. They can for most be done, but it's a lot of work. And we will see now more details now. Basically what we want to do, we say, okay, we have an IFC file. Let me see where I can push here. It's okay. Well, it's not important. We have the IFC file. We read the IFC file with a library that's called IFC OpenShell. IFC OpenShell is a super nice library. You have the binding for Python. So once you have the binding for Python, you can read everything into pandas. In pandas, you can do some calculations, for example. There's a particular way how pipes, as I said, we will talk about the drinking water network. So we have pipes. And one might think that the pipe in IFC is 0.1, 0.2, and then the straight line connecting them together, but it's different. Because they say, okay, we start from a certain point, then you give me the cross-section, which might be circular or rectangular or quadratic, whatever, and then you give me the direction where you want to point to, like a gun, and then you tell me how long it is. So basically for transforming it from the representation of BIM, you have to do some transformations, like say, okay, start from this point, take the direction, go for that many meters along that, and then you have the end point. That's easy, that can be done. In pandas, it's done quickly. Then from pandas, okay, obviously with the geospatial extension, GeoPandas, you write everything to PostGIS, and then happens some magic that Francesco mentioned before, that's called OnTop. OnTop has super power to transform Sparkle to SQL. And then at the end, we have our GeoSparkle thing. Okay, that was the initial thing that was quickly done. I guess it was kind of work of a week of work. And then a lot of problems came up. Just one word about the virtual knowledge graph things. I said there was already some explanation that basically a knowledge graph is something where I say, okay, I'm Peter, and Peter is a person. That person lives permanently in this moment in Merano. Merano is a town. This town is in South Tyrol. South Tyrol is a region of Italy. That region of Italy lives in the Alps. And always you have one of those links connecting one concept to the next one. That's the cool thing about graphs. You can really put a lot of knowledge into very naturally in the graph, so therefore it's very, very, very good for having knowledge in the computer memory. What does OnTop? And OnTop says, okay, you have data in your database, in your files, in your Excel file, in your CSV file, and a lot of other things. We can create a graph out of that data. That's what a lot of other software can do. But OnTop does it a little bit differently. It only constructs those tiny pieces of graph that you need at that moment. So in your query, say, give me all cities of South Tyrol. Then he transforms it smartly and says, okay, I only query the cities of South Tyrol and not every city of the world. So that's what we call a virtual knowledge graph. As I said, it's might seem trivial. There are quite some tricky things to do, but it does it quite well. And we have a number of papers who demonstrate that it works well, also from different research groups from Bolzano and otherwise compared. Fine thing, magic. I don't know how it works. I'm not doing it, but it works fine. Now about the tricky things of why that simplification from super detailed to simple does not always work. So in GIS, a network has a geometry, and usually a network has something that's called a topology. So topology says what is connected with what, but it says it explicitly. It's not simply by, okay, it's near to, so it must touch. It's really, okay, this is connected to that. Very similar, for example, if you have some drawing programs, like if you're using Google Slides, you can really attach to a point. So if you're moving that piece, it moves, all the connections to it move to. So you have every edge in that thing is connected to nodes, a starting node and an end node. Seems to be simple, but in all that super amount of BIM files, that information is not there. So basically you have to force who creates the file to say, you have to put this information into the file, because I can try to guess if it touches, but that's always risky. This is the first problem. The second problem, or second thing is, it's not really a problem, it's always more work than you expect to have, is GIS people say, okay, I want the essence of thing. I do not care about all those tiny details. So if I have one pipe and then I have a next pipe and a third pipe and a fourth pipe, I do not want 4 objects. I want one object with the complex geometry of the everything. So okay, you have to kind of join all those things together, and you do that. You say, okay, if they have the same diameter, same material, I can join them, and for the G-spot it becomes one thing, so it's easier to query. One more work is then say, okay, but it might not only be pipes that touch together. 2 pipes maybe, if they're not in a straight line, they might be connected by an elbow. That's a curved segment. In BIM, a curved segment is quite different from a pipe. It's really an explicit geometry with the triangulations part of thing. So you have to do, okay, now how do we handle that? So again, you have to think about it and you have to implement it again, days and days of work until it works fine. Then what happens sometimes in the BIM file, it's not guaranteed that each pipe has on both sides another object. Sometimes it's simply finished there, and just I say that's not possible. So okay, I say, okay, we have a kind of ad hoc mechanism called virtual nodes, so we simply add some nodes for where we need them, but they are not in the original file. One more thing is if we have kind of a T piece, like all point objects in BIM, those have a spatial extension, so it might be small, big like this, the T piece, but it has an extension. But it just, the point is a point, it's a mathematical point, it has no extension. So you have to find a way to interpolate again the new geometry so that you have no gaps in the new geometry, because if you simply take away the T piece, you have a gap, so you have to close that gap. So again, you have to do more calculations, more calculations, more calculations. So everything that initially seemed to be simple, it adds work and more work and work. You can solve all of them, but it has to be done, and that's not always trivial. Yeah, we're coming to an end. As I said, most of things can be done. Sometimes you have to go back to data producer, say, okay, listen, I can try to guess what you meant, but I'm not always sure. So, but if you fix it upstream, so I can import things correctly and pass them over to the data consumer in a correct way. In the end, we managed the thing. This here is QGIS visualizing our geometry with a small plugin for querying GeoSparkle that's called Unicorn Sparkle. It worked. It's in the correct position. It makes sense how it is. Okay, it was done. It took, I guess, 4 or 5 times more time than we initially expected, but with enough substance, you arrive to the end. So what's one of the things that you always come out to? If you switch data from one domain to another domain, unexpected things might happen. Sometimes small issues with data quality that in the initial domain are not very important, they come up because in the other domain they are important. So it's like in the real world, sometimes you have some small cracks coming up. When you move things, they come up here. It's not always the same definition of what is correct in one domain to the other domain, and once you cross the domain boundary, those things come up. So the thing is really, you can reuse data, you can do a lot of things to unify data, but never underestimate the effort to do it. It might be sometimes easy, most of the time. It takes some skill and it takes some intent to really come out of it. That's it. If you're interested what On Topic is doing, just contact us. We are there.
Thank you, Peter. We have already one question there.
Hi, thanks. Hi. I didn't really understand which kind of details you had to sacrifice going from BIM to GIS. Like, for example, are the resulting geometries 2D or still 3D, and which kinds of other details that you have in the BIM did you have to leave out?
I guess the answer is easiest to give visually. This is the BIM file. You have the real geometric objects.
Mm-hmm.
You see, for example, the hydrant has this shape and not another one. The elbow down there over the P, on top of the P. There's really the exact geometry of the elbow. The shutter there, the flow controller is exactly shown how the geometry looks like. In GIS, what we have is, in the end, this two-dimensional thing. So we do not have the exact geometry of the flow controller, of the hydrant, of the elbow, because from the level of analysis of GIS, it's irrelevant. It's not important.
Okay. And the buildings that you showed also in the other slide, that becomes like a rectangle.
Here we only managed the the infrastructure, but you could do the same thing with buildings, and then you simply define the polygons that you have are in some way calculated from the BIM file. But it's always, as I said, it might be tricky, but you might have the outline of the roof, which is different than the outline from the sedime, which is different from the outline of the everything covered by the building. So again, you switch from one domain to the next one, and the translation can be done, but it's tricky.
Thanks.
Very quickly.
Maybe quickly. Now you went from BIM to GIS.
Yeah.
And did you also come up with some recommendations how to properly define a BIM in case you want to do this conversion again? Probably you have some points where you say better
absolutely.
define the BIM.
If you, for the infrastructure, in BIM you can give the topology. So please do it if you want to use it as GIS. Because, but in BIM it's a little bit tricky because you simply say you have that connection point and then you have to connect the things to the connection point. So it's more work, and usually planners, designers do not much care about that, but for GIS it's important. So there's a way to define explicitly the connectivity. It makes sense to do it then.
So thank you, Peter.
Yeah.
So, Mr. Piero Campalani from our research, he will present ClimDex Kit, which is an open source tool for processing and visualizing climate indices, which is to support climate change studies and communication. So, please.
Thank you very much. Well, first of all, it's a pleasure to be here. It's my first SFS Con, and it's a really great conference, so congratulations to everyone. Thanks also for not saying last but not least, which is automatically said every last talk. So yes, hi everyone. I'm gonna talk today about ClimDex Kit. So again, it's a toolkit for studying climate change and communicating climate change to the public. No idea about the effort behind naming of things. The effort of those bunch of letters has been really headaches, and it's now done. So, by the way, ClimDex is climate index, but yeah, we will
see now what that means. So first of all, who are we? So Alice on the right, she's the real mastermind of all this. She's the scientist, the climate researcher, and I'm just the mere keyboard for this. But we designed together the whole package, and yeah, that's our work. So first of all, a bit of background. You might, not all of you know much about climate stuff, even though now it's a lot of talking about it. So let's do a bit of background first. Climate change, yeah, we all know that already, I guess. Yeah, polar bears send their gratitude and best wishes to us every day. So, talking about future climate projections, what it is? You might have seen these kinds of charts recently. Anyway, so you see here, we have, this is the historical data of like some climate or emissions, and then you have possible scenarios, okay? So depending on if we are being good or bad, business as usual, we have different so-called emissions scenarios. So, well, first of all, RCP that you see here, that stands for representative concentration pathways, but just forget it, doesn't matter, it's just emission scenario, that's simpler to remember. The time scale of climate projections is usually, I mean, from whenever we have the data, so 1980 usually, up to 2100. That's the time scale for the so-called projection. And so yeah, again, these are all different colors. You have the different scenarios of greenhouse gases, CO2 equivalent emissions. Then another concept, so climate ensemble. So ensemble, you know, that's a group, a set. So it's a set of climate models. What is a climate model? A model is a complex thing which tries to model the whole climate system, which is, as you can see here on the right, the composition of 5 different elements. You have atmosphere, biosphere, lithosphere, cryosphere, and hydrosphere. So all these 5 things, all the relationships, that's a climate model. And then a set of them is the ensemble. So why do they work with ensemble is that, as you might feel looking at this, working with the aggregation of different climate models, you get more robust results, more stable. So that's why usually climate scientists work with this. Okay, then another concept, another background concept. So climate indices. So what again, the Climdex packages from Climate Index. So what are they? So you might think of them as something that levels up in the usual information pyramid. So you want to extract more anthropic information out of the climate projections. So first of all, a few examples just to give you a concrete idea of what a climate index is. So, well, the definition is it's a diagnostic quantity that is used to characterize and quantify an aspect of a physical system. Okay, just go with the example, it's simpler. So, for example, how many tropical nights will we have per year in the future? That's a kind of climate index. Okay, tropical nights are nights that don't go below 20 degrees. Okay. Then, how will the frequency of dry spells per year evolve from now? Or how intense will the annual maximum one-day precipitation be by 2050? That's my colleague Alice wrote that. It's more don't mind if you don't understand that. But anyway, so we have here the climate projection. So it's a huge amount of data, predictions up to 2100 of climate variables, like imagine temperature or precipitation and stuff. And with climate indices, you get a smaller amount, but of more significant information. So that's the idea. So why did I draw cubes? That's made on purpose, because usually when we treat this kind of data, geospatial data sets, we work with data cubes. You might have heard it somewhere in. So usually for Earth's observation, you have nicely, regularly gridded data structures, so like multi-dimensional arrays. So they are usually modeled with data cubes, or hypercubes. You can have more than 3 dimensions, but it's just the simplest, dumbest form, regular grids, So it's nothing really complex, but they are analysis ready. So because they are simple, they're best suited for analysis from everyone. So for example, if you can get a glimpse here, you see you have different bands, and you can very simply filter through space, time, get aggregation through the different dimensions, etc. Okay, so let's talk a bit more about the package that I implemented. So it's called ClimDexKit again. This is, you see it on the Python packaging index. It's there for everyone, open license, etc. So the motto we chose is compute, publish, analyze. So this is a kit to do these three kind of things with climate indices. So yeah, you want to compute them out of the input climate projections. You want to publish them to make them available online or just in your laptop. And then you want to analyze them, so to get even more up in the information pyramid, you know, and get some useful information for both researchers and the public anyway. As you see here, the analyze part is still a bit of work in progress, but it's just to be transparent. So, okay, first thing, compute. Okay, so you have the ClimDexKit here, and as you see, it's relying on the different backend options. So the ClimDexKit doesn't actually implement algorithms to calculate the indices. It relies on much more robust and better libraries like the CDO one. You might know Climate Data Operators by the Max Planck Institutes or other whatever. And so the ClimDexKit just orchestrate the inputs to the different backends. So what are the good things? It's highly parallelized for calculating the indices. It's customizable. You see here, different user can have their configuration. That's pretty basic software hygiene. Nothing to be super proud of, but it's there. Well, configuration here means every user can have a different set of indices or can tune a bit the different thresholds for a definition of index. So you can have a lot of customizable options there. And hides a bit the complexity of the different backends in a way. And then it's natively implemented as to be easily pluggable with other backends. That's a bit the idea. This is a big picture of, again, the compute part. So on the left side, you see the input climate projections, so the big ones. And on the right side, you have the output, so the climate indices. All these little nice cubes are netcdf files, actually. So they're usually 3D time series. And you see they are here in the same bag, which form, as you remember, the ensemble. And each ensemble is representing some different climate variables, like you see here, precipitation, maximum temperature, minimum mean temperature, and etc. So that's the data structure and input. And so it's everything repeated the same for different emission scenarios. You remember that as well. So for example, here above you see RCP 4.5 and RCP 8.5. So that's the situation. And in output you have a similar structure, but instead of the input you have climate indices. And does any of you know the CDO? Ever work with the CDO, Climate Data Operators? Oh, yeah, I know you. That's just to whatever, just to show, see the face of definition of how to compute an index, but it's not important. Second part is the publish. So, okay, we then computed our climate indices, and we have our netcdfs in our computer, server, whatever, and we want to make them available to the people. So these are the indices, again, this cube, and with this OpenEO platform and API, which is a way to make the sharing and replicability of processing of Earth observation data in a very transparent, open way. And so just very quickly, not going into details, just understand that with this in the middle, all your climate indices are available to other researchers for like R client or Python clients, whatever, web editors, to make analysis on them, make whatever they want. This is for also good for fostering the FAIR principles, which are always on our minds. And yeah, it's all open standards, and that's good. This is still, just to give you an idea, you have to have a spatial data infrastructure to publish your data with OpenEO. So it's just don't do it at home on your laptop. This is what we have at URAC Research, just a glimpse. For example, here you see we have the server with OpenEO, which is backed up by 2 different database servers, Rastaman and OpenDataCube, for example, just different options for storing the cubes. And then you have the GeoNetwork catalog, which harvests the collection, all the catalog, and is linked to a confederation of catalogs in the open public, like the Geos portal in our case. So that then your data is really like reachable from anyone, and it's public. Yeah, don't look at the other details. It's finally the analyze part. Okay, so as you see here, we thought of 3 different categories of like results or types of analysis you want to apply on a climate index. The first one is just get some spatial maps, okay, so of some kind. So here you see this is South Trentino and South Tyrol. This is the summer days, which is a climate index. So summer days taken over this area, and you see here we have the number of days in a year for different scenarios, or you have the difference between the summer days of some reference and some other period, for example. So this is just to give you an idea of the kinds of results. So we're thinking of multi-year aggregations, like, just minimum or average, whatever you want. Baseline comparison. So in climate, in the climate data science, a baseline is a period of reference. So usually in this case of studies of climate change, you want to compare the baseline of 1980s till today with the behavior of the 2050 to 2080, which would be worse. And that's called the baseline. So making comparison with baseline behaviors and visualize a map. Scenarios comparison, like different emissions scenarios, that's also very useful. Ensemble aggregation, so you have here what you see here, for example, it's the average of all the different models that compose the ensemble, but you might want to get another kind, the median or the maximum or whatever. Want to give the possibility to get absolute values or differential ones, like the difference or the ratio of values. And also that's important to be the ability to filter by the elevation. So we also provide a digital elevation model, so you can say, I want to know the summer days, but just for the areas below 700 meters altitude. That's relevant for climate. So that's important to have. The second, big category, temporal trends. So no maps, but just nice temporal trends of how things will get worse. And this is basically the same kind of analysis, just instead of see a map, just see that over time. And then finally, this is also very important, the ensemble analysis. You want to go inside the ensemble and see the behavior of the models inside the ensemble. So for example, how many models agree on the sign of projected changes within the ensemble. So if you have a trend that says the summer days are going to be more in 2050, you want to see if all the models within the ensemble say the same thing, or there is some who says the other way around. So that's an important thing to understand. So very quickly, finally, this is free open source, of course, and that's why we're here. Fair principle and highly customizable. That's maybe more important to say what's next. We want to work more on the uncertainty analysis, which is really important and some always overlooked. And well, most importantly, we want to build from this an interactive web portal to for both the researchers and the public to go and see how the climate will change in the future. So there are a few links. Contact us, climate stuff related, Alice. And yeah, that's all. Thank you very much. Sorry for the delay.
Thank you, Piero. Thank you, Piero. I think we have no time for questions, but of course, I think they will ask you. So thank you all. We can close this track for today. And so I wish you a nice evening.